Hi guys, Daniel here. Hope you guys are doing well. So today we've got the AS paper for paper 1 pure mathematics for June 2023 Edexcel. And yeah, there was quite a few questions in here. There was 17 in all, so it took a bit of time, but we've got it done now. And yeah, this paper is just probably for students that are in year 13 that probably want to consolidate what they've learned last year, and obviously for year 12 as well. But obviously if you're in year 12, make sure you've gone through the entire syllabus before you start attempting past papers anyway. That's just my advice. But yeah, you will have the timestamps in the description so you can easily access whatever question you'd want to go to or navigate to whatever question you'd like. And yeah, that's pretty much it from me. Let's get into it. Okay, so question one says a curve has equation y equals 2 over 3 x cubed minus 7 over 2x squared minus 4x plus 5. Part A says we need to find dy dx, writing your answer in the simplest form for 2 marks. Okay, so this one isn't too bad. So I'm going to put A here. We've got y is equal to 2 over 3 x cubed minus 7 over 2 x squared minus 4x plus 5. We need dy dx. So this is very straightforward. All we're going to do is just use the power rule, bring the power to the front. So I'll drop that to the front. It's going to be 3 times 2 over 3 x squared. Power drops by 1. And we're going to do the same thing. It's going to be, the 2 is going to drop to the front, so it becomes 2. And then times 7 over 2 x, and then 4x will go to 4, isn't it? So it'll be minus 4, and we know that 5 goes to nothing. So this is going to be our dy dx. Now we need to simplify, so I'm going to say dy over dx will equal, 3's will cancel, will be 2x squared. The 2's will cancel, will be minus 7x, and then minus 4. And that will give us our 2 marks. Part B says, hence find the range of values for x, values of x for which y is decreasing, for 4 marks. Okay. So remember, when your function is decreasing, it means that your gradient is negative. So all you're going to do here is just say that dy dx, your gradient function, has to be less than 0 for your function to be decreasing. So all you're going to do is just set your dy dx, your expression for dy dx here. So 2x squared minus 7x minus 4. You're going to set this less than 0 and solve this quadratic inequality here. Now, to solve the quadratic inequality is very, very straightforward. You always want to sketch this graph. So what I'm going to do is I'm going to get axes like this, and then I'm going to plot this graph here. Now, the y-intercept is quite clearly at minus 4, so I'll put that there. And now I need the roots. So what I'm going to do is just solve. I'm going to solve 2x squared minus 7x minus 4 is equal to 0. Now, this is A-level math, so you can just put this into your calculator, which is what I will do. So I'm going to go here. I'm going to go to menu. I'm going to go to equation. I'm going to go to 2 polynomial and 2 again. And I'm going to put the coefficients in 2, negative 7, and then negative 4. This is equal to one value of x is going to be positive 4, and the other value of x is going to be minus a half. So those are our 2 values of x. So that means it will go there. That's going to be minus a half. And let's just say 4 is here. And then the quadratic itself, I'll do it in red, is going to be something like this, isn't it? Turn up, it's going to be a bit to the right. So like that, essentially. This is our quadratic here. This is the graph of 2x squared minus 7x minus 4. And we need to find out where this graph is less than 0. And that is just underneath the x-axis, which is going to be for this part of the graph over here. Now you need to ask yourself, well, for what values of x does this occur for? You can see quite clearly it's going to be in between the roots, isn't it? Minus a half and 4, not including it, right? So your final answer is just going to be minus a half, it's going to be here, and then less than x, and then less than 4. And that will give you the 4 marks. And that's question 1 finished. Okay, so question 2 says, using the substitution u is equal to root x or otherwise, solve 6x plus 7 root x minus 20 is equal to 0 for 4 marks. Now, they've given us a substitution, so what I'm going to do is attempt to get everything from x in terms of u. So I know that u is equal to root x, and I can see a root x here. I just need an x now. Well, if u is equal to root x and I need an x, I'm going to square both sides, aren't I? So I'm going to say u squared will equal x, wouldn't it? Now I've got x in terms of u, I can punch this in. So that means the equation will become 6, and then it's going to be x, which is u squared, plus 7, and then root x is u. So I'll put a u here, so 7u minus 20 is equal to 0. And we can see quite clearly that this is just a quadratic. So this is a disguised quadratic, which comes up quite a lot. Now I need to solve this. What I like to do is punch this into my calculator and get the roots. But it does say here, solutions relying on calculator technology are not acceptable. So I'm going to factorize. And because this is a quadratic where the the a term is more than 1, so 6 here. I need to times this number by the c. So 6 times minus 20 is going to be minus 120, isn't it? So I need two factors of minus 120, which will also add to give 7. Now, what are those two factors? Is it going to be 6 and minus 20? No, that'll make a minus 14. 4 and 30, 40 and 3? No. What can it be? 15 and 8, I believe. 15 and 8. Positive 15 and minus 8. Those add to make 7. Does that time to make minus 120? 15 times minus 8. Perfect. So it's these two. Okay, so we've got our factors. Now what you're going to do is you're going to break this down. 6u squared plus, and then instead of writing 7u, I'm going to write what it adds to make with these factors. So it's going to be 15u minus 8u minus 20 is equal to 0. Going to factorize the first two terms. I can take out a 3u, can't I? And then inside I'm going to get a 2u here, and then it's going to be plus 5. And then what I can take out from here is going to be a negative 4, no? And then I'm going to have a 2u. It's going to be plus 5 again, is equal to 0. Quite clearly, we can see we've got the same factor twice. So I'm going to bring that out. So if I bring that out, I'm going to have 2u plus 5 in a bracket. And then we're going to be left with these two here, isn't it? 3u and a minus 4 in a separate bracket. So it's going to be 3u minus 4 is equal to 0. So we factorized it. And then now, what I'm going to do, actually, let me just highlight this so it's clear to see what's going on here. So I've got that factor there, and I've got this one here. Okay, so we factorized it. We just need to make each of these factors equal to 0. So 2u plus 5 is equal to 0 will mean that 2u is going to equal negative 5, meaning that u is going to equal negative 5 over 2 for one answer. And 3u minus 4 is equal to 0 will mean that 3u equals 4. So therefore, u is going to equal 4/3. Okay, so we've got two values for u. Now remember, we're asked to solve an equation in terms of x. So this is not our answer because we need x. This brings us back to our substitution. So we're going to put that back in. So it's going to be root x will equal minus 5 over 2. And root x will equal 4/3. Now, when you are here, it's very tempting to just square both sides. But you need to remember, we're dealing with root x is equal to something. Now, remember the graph of root x. The graph of root x looks something like this, doesn't it? Let's just say this is my axis over here. Just bring this here a bit. This is my axis here. Root x is just above the x-axis, isn't it? It's like this. Yeah, I'm going to put y here and then x here, like that. This is the graph of y equals root x. So if I was to solve this equation, I'd be saying root x is equal to minus 5 over 2. I need this graph to intersect the line of minus 5 over 2, which is going to be down here, isn't it? Let me draw another line like this. Minus 5 over 2 is underneath the x-axis, like that. There are no points of intersection here, so there's going to be no solutions for this one. So we can't solve this one, right? So the only answer is going to come from the second solution. Root x is equal to 4/3. So we square this now. That's going to be x is equal to, squaring that will be 16 over 9. So the only answer for this one is x is equal to 16 over 9. And just always be careful whenever you see this again. Just remember to sketch the graph, or you don't have to sketch it. If you don't remember it, you can just visualize it. Anything underneath, which will be a negative value, won't work. So your answer is going to be 16 over 9. And that's it for question 2. Okay, question 3 says, Figure 1 is a sketch showing the position of three phone masts, A, B, and C. The masts are identical and their bases are assumed to lie in the same horizontal plane. From mast C, mast A is 8.2 kilometers away on a bearing of 72 degrees. Mast B is 15.6 kilometers away on a bearing of 39 degrees. Part A says we need to find the distance between masts A and B, given your answer in kilometers to one decimal place for 3 marks. Okay, so what I'm going to do, I'm going to screenshot this diagram here, or figure 1, and I'm going to put this here, and I'm going to add all of the information that we know about this diagram. So from mast C, we know that mast A is 8.2 kilometers away. Okay, so I'm going to draw a line from C to A. It's going to be like that. And what I know, let me just line it up. What I know is that this is 8.2 kilometers away, isn't it? So I'm going to put 8.2 kilometers here. And I also know this is on a bearing of 72 degrees, isn't it? So I'm going to just put a 72 degree angle here. like that, and I'm just putting inside. Yeah, I put it inside here, 72 degrees like that. Okay. And what I also know is Mast B is 15.6 kilometers away from C. So I'm going to draw another line from C all the way to B, which is going to be like that. And whoops, I need the line. Just one sec. Need the line. Let me just line that up. Okay. And then now, what else do I know about this? So I'm doing a different color. The angle, the bearing is 39 degrees. So that's going to be a 39-degree angle here, isn't it? And what I also know is that distance here is 15.6 kilometers. So I'm going to put this here. And what are they asking us to find? Asking us to find the distance between A and B essentially, right? So I'm going to draw another line like this here. And let me do it there. Okay, so we're trying to find that distance here. So we've got a triangle going on. So it's definitely going to be trig. Now, what else can I decipher from this image? Well, that is a 39-degree angle over there. This red one is 39. I know the entire one from the north line to the line where A and C are is 72 degrees, which means I can calculate this angle in yellow here. The yellow angle plus the red angle must make this 72-degree angle, and that's going to be 72 take away 39, which is going to be 33 degrees, no? Yep, that's correct. 39 plus 33 is 72 degrees. So that is helpful because what I'm going to do now, I'm going to just draw one more triangle just to replicate what I've got here. It's going to be something like that, isn't it? Something like that. And this is going to be 33 degrees. That's going to be 33 degrees. This is 15.6 kilometers. And this is 8.2. 8.2. And this distance here is what they've asked us to calculate. So we can see that we've got two sides and the angle in between. It's going to be the cosine that we're going to be using. What I'm going to do, I'm just going to label this. I'm going to call this A. I know it's C here, but I'm just going to call this A. This is my own triangle. And that means that the question mark is going to be lowercase a. I'm going to call this capital C. That's going to be lowercase c. I'm going to call this lowercase b. I'm going to call this capital B. Now, the cosine rule states that if I'm looking for A, then it's going to be A squared is equal to B squared plus C squared minus 2BC cosine of A. Plugging in everything that we know, it's going to be A squared is going to equal B and C, 8.2 squared plus 15.6 squared minus two lots of those same two sides, 8.2, 15.6, and then cosine of the angle, which is 33 degrees. So I'm going to put this in my calculator, square root, and that will give me A. So let me put this in. My calculator is right here. It's going to be 8.2 squared plus 15.6 squared minus two lots of 8.2 and 15.6 cosine of 33. Make sure my calculator is in degrees. It is. Let me just check. 8.2, 15.6. Yeah, that's fine. Minus 2. That's okay. That's okay. So that means that A squared will equal 96.034, meaning that A will just be the square root of that. So I'm going to just do root answer. And this gives me 9.7997, which is 9.8, isn't it? To three significant figures. So I'm just going to say 9.8 kilometers. And that will give me the answer for part A. Now, part B says an engineer needs to travel from mast A to mast B. Give a reason why the answer to part A is unlikely to be an accurate value for the distance the engineer travels. Okay, so what we're dealing with here, we're dealing with phone masts, right? Which are obviously on land. And when you're on land, there are buildings and stuff, right? So probably it's probably not going to be just a direct route to A and B. There could be things in the way, which would probably which will make the distance greater, right? Because it says give a reason why your answer to part A, which is the distance between A and B, is unlikely to be accurate value. So just due to that, you could just say that it's probably going to be greater. There could be things in the way, as well as that. Also look for assumptions. It says that the bases are assumed to lie in the same horizontal plane. That's an assumption. It may not do, right? So there's a couple of things you could say, but just essentially, you're just going to say for part B, uh, there may be, or most likely, there may be, or most likely, maybe objects in the way of A and B. making the distance, making the distance greater than what we calculated, greater. So something like that. Apologies for the handwriting. It's very difficult to write on this tablet. But yeah, that's pretty much it. And that will give you the full marks for question 3. Okay, so question 4 says sketch the curve with the equation y equals k over x, where x is never equal to 0, where k is a positive constant for 2 marks. All right, so this is just the reciprocal function, isn't it? Right. So what I'm going to do, I'm going to get axes going. It's going to look something like that. And then I'm just going to say this is going to be part A. Now, because k is positive, the curves are going to be in the top right quadrant here, and the other one's going to be in the bottom left, like this. And then obviously I'm going to put this as y, put that as x, and I'm just going to say that y is equal to k over x. Now remember, if k was negative instead of positive, then it would be like this, wouldn't it? Like that. But it's not, so we don't need to do that. So yeah, that will give us the 2 marks. And then part B says hence or otherwise solve 16 over x is less than or equal to 2 for 3 marks. Now you may be tempted to just solve this algebraically, but it's actually easy if you just visualize it, and it does say hence, so you should do something with part A. Now what I'm going to do is I'm going to sketch this again, right? But k is positive, and in this case it's 16 over x. I'm just going to sketch the same thing, but just say that k is equal to 16. So I'm going to sketch this. I'm going to copy this and paste this here, and then put this underneath like that. I'm going to call this part B. We'll say this is part B, and I'm going to change this to a 16. And remember, what are we solving again? We're solving 16 over x is less than or equal to 2. So I'll just write this here. 16 over x is less than or equal to 2 is what we're trying to solve. We're trying to find the values for x which satisfies that inequality. Now, I've got 16 over x here. Now, let's say it was equal to instead of less than or equal to. I'll need to see where those where the curve intersects the line. So what I'm going to do is I'm actually going to sketch y equals 2, right? Now, y equals 2 is just going to be a horizontal line going through 2, isn't it? So I'll just do it there, and I'll do it in a different color. So I'll do it like this. That's going to be 2. Let me just make it horizontal. That's fine. And then let me rub out that 2, put it on top, do it in red. It's going to be a 2 there, and I'll change this to a red line 2. Okay, so we've got that. Now, when I look at this, I can see that they intersect each other at only one point. Yeah? So I can say that there's going to be one value of x that we don't know at the moment, whereby 16 over x intersects the graph of y equals 2. What is that value? Now, I'm going to find it just by solving it. I'm going to say 16 over x is equal to 2. 16 divided by what will give you 2 is 8, isn't it? So I'm going to just say x is equal to 8. So I can say that this value here, which I've labeled x, I now know that's 8. Now, looking at the inequality, it says we need to solve 16 of x is less than or equal to 2. So we know where it's equal to. It's equal to when x is 8. Where is it less than? In other words, where is the graph underneath the horizontal line? And we can see quite clearly it happens here, right? And it also happens here, right? These parts of the graph is where the curve, sorry, is underneath the red line, and it's greater than for this part here. Yeah, so it's always good to just try and highlight or just distinguish each part, right? So we can see quite clearly that the graph is underneath the horizontal line y equals 2, where the graph is highlighted in yellow. Now you need to ask yourself, well, for what values of x does that occur for? Well, remember, for this one here anyway, it's to the right, isn't it? So it's going to be values of x which are greater than 8. Now remember, the inequality is less than or equal to 2. So it can be equal to 2, and it's equal to 2 at 8, and it's less than 2 underneath going to the right. So it's going to be, one answer is going to be x is greater than or equal to 8, right? Because it's equal to 8, which is fine. It's equal to 2, sorry, when x is 8, and it's underneath the red line for values of x more than 8. So this is definitely going to be one answer. Now the other answer is for this part here. Now this part is when x is negative, isn't it? This is just when x is less than 0. So all you're going to say is or x is less than 0. So these are going to be your two answers. I'll just write like this again. It's going to be x is less than 0 or x is greater than or equal to 8. This here will be your final answer, and this will give you the 3 marks. And that's it. Okay, so question 5 says the finite region R, shown shaded in figure 2, is bounded by the curve with equation y equals 4x squared plus 3, the y-axis, and the line with equation y equals 23. Show that the exact area of R is equal to k root 5, where k is a rational constant to be found for 5 marks. Okay, so they've given us a graph here, and there's a shaded region R. This is a classic case of a definite integral question, right? Now, what I always do before I actually start working things out doing algebra is to visualize how I would actually calculate that region there. Now, we know it's integration because of the fact that we've got a curve, we've got a region, and so on and so forth. Now, what you always want to remember is if you want to calculate the area bounded by a curve, right? It's just definite integration. So I've got this quadratic here, and what I'm going to do is I'm just going to draw a vertical line going downwards like this, like that. And for example, let's just say I was to call this B right here, and let's say I was to call this A. If I wanted to calculate this region right here in yellow, all you would do is just integrate between A and B of your function. So in this case, I can say that that will just be equal to the integral between A and B, whatever those are, of 4x squared plus 3 dx, right? Whatever this is equal to, given that we know A and B would be equal to this yellow region here. Now I need the gray region, right, which is a shaded region. Now the way we calculate shaded regions, even from GCSE, is that you're always going to take one area and subtract it from another. And the fact that we've drawn a vertical line is quite helpful because we've actually got a rectangle. So what I'm going to do is say then, okay, if I look at it, if I wanted to calculate that region shaded in gray, then for me, that would be equal to, I'm going to call this R. This would be equal to the area of the entire rectangle, whatever that is, like that. And then surely I would just take this region away, right? You can see that quite clearly. If I do the rectangle, take away that one, it will leave me with this gray region here. So your job is to just figure out what those areas are, subtract them, and then you're done. Now, how do we do this? Now, firstly, if we start with the rectangle, we can see that quite clearly. The vertical height of this rectangle is 23, isn't it? So I'm going to put a 23 over here because that's the vertical height because it goes up to 23 on the y-axis. Now we need the base, meaning that we need to figure out what A and B are. Now, A is quite clearly the origin, isn't it? So A is going to be x is equal to 0, to be fair. So I'm going to say that, I'm going to say x is equal to 0, yeah, for that one. So I'm just going to say, I'll do it here. I'll say A is equal to 0. Now, what is B equal to? Well, if you look at B, if I do this, right, we can see that there is a coordinate here, and that's going to be B, and it's going to be 23, isn't it? And that passes through our curve, y equals 4x squared plus 3. So what I can do is punch this into the equation, the formula, and then rearrange to figure out what B is, right? Which is going to be our upper limit. So I'm going to do that here. So I've got y equals 4x squared plus what was it? It was 3, isn't it? Yeah. Y equals 4x squared plus 3. And I've got the point B 23, which I know passes through the curve. So I'm going to punch this in. And this will give me 23 for y will equal 4x is b, 4b squared plus 3. Take 3 over, it's going to be 20, it's going to equal 4b squared. Divide 3 by 4, I'm going to get 5 is equal to b squared. And I'll just swap it over. That means b is going to equal square root both sides. It's going to be plus or minus the square root of 5, isn't it? Root 5. Now, when we look at the diagram, we can see that b is clearly positive because it's to the right of the origin. So we're not going to use the negative solution. So I'm just going to say b is going to equal positive root 5. But always, as a habit, just do plus or minus when you're square rooting. So we've got b is equal to positive root 5. How is that helpful? Because we now know that this is going to be, I'm just gonna say here, this is a equals 0. I'm gonna say b is equal to root 5. This is helpful because I can say that this is 0 here, that's a root 5. The base of this rectangle is just going to be root 5, isn't it? Meaning that we can calculate the area quite easily. It's just going to be 23 times root 5. So I'm going to just say it's going to be so it's going to be 23, sorry, root 5. And I'll put this in a circle. This is the area of the rectangle, which we now know. Now, this is also helpful because it will allow us to calculate the area of the yellow region here. Because remember, we said at the very beginning that this is just a definite integral, right? Integrating our function. So all we're going to do now is just, I'm going to copy this. And we now know our upper limits. We now know our lower and upper limits, a and b, 0 and root 5. So I'm just going to put this here, grab this here. And what I'll do it on the next page, actually. So we'll put this here. And since we know our limits now, we can just easily work this out. So I'm going to say this is going to be equal to then the integral between 0 and root 5 of 4x squared plus 3 dx. Now, integrating this, let me just put my square brackets. We're going to add 1 to the power and then divide by the new power. So that's going to be 4x to the power of 3 over 3. And then plus, and then this will become 3x, wasn't it? We're going to integrate between 0. We're going to evaluate between 0 and 5. 0 and root 5, sorry. I'm just going to put this in now. So if I was to put this in, it's going to be 4, and then it's going to be root 5 all cubed divided by 3 plus 3 root 5, isn't it? And then minus, and then remember these are both x's. It's just going to be 0 plus 0. So it's going to be nothing for the lower limit, isn't there? So it's just we just need to work out what this is. Now, if I put this into my calculator, will this simplify it for me directly? It may or may not. Let's have a go. So I'm going to do 4. Let me get a fraction going. 4, and then it's going to be root 5 cubed over 3. Whoops, over 3 plus 3 root 5, isn't it? Root 5. This gives me 29 over 5 root 3. So it's going to be 29. What was it? Sorry, let me just again. 29 root 5 over 3, sorry. 29 root 5 over 3. That is going to be our answer to this area here. 29, let me just double check what it was. Yeah, root 5 over 3. So therefore, the answer to the region R is just going to be 23 root 5 take away 29 root 5 over 3. So I'm going to say, therefore, R is going to equal 23 root 5. Yeah, 23 root 5. Take away that area there, 29 root 5 over 3. And I'll put this into my calculator and see what it gives me. 23 root 5 take away 29 root 5 over 3. So I need to put in a like that. This gives me 40 root 5 over 3, 40 root 5 over 3, or 40 over 3 root 5. Either one is perfectly fine. And that'll be it, and that'll give you the 5 marks. Okay, so question 6 says, the circle C has equation x squared plus y squared minus 6x plus 10y plus k is equal to 0, where k is a constant. Part A says we need to find the coordinates of the center C for 2 marks. Okay, so this is just a circle question. We need to complete the square to get it in the form of x minus a squared plus y minus b squared is equal to r squared. So I'm going to just, part A here, I'm going to write this out again. So x squared plus y squared minus 6x plus 10y plus k is equal to 0. I'm going to complete the square. So firstly, what I'm going to do is I'm going to bring the x's and the y's together. So x squared minus 6x, and then plus y squared plus 10y, and then plus k is equal to 0. Now, I'm going to complete the square. So this will give me x minus 3. Remember, we're going to divide that by 2, the minus 6. And then we're going to take away the square of this number, which is going to be taken away 9. And then plus, again, we're going to half the 10, so it becomes y plus 5, all squared. And then we're going to take away the square of that 5, which is going to be 25. And we've still got that plus k here is equal to 0. Now, I'm going to say we've got x minus 3 all squared, plus y plus 5 all squared. And then we've got minus 9 minus 25. That's going to be minus 34. Plus k is equal to 0. Now I'm just going to move this to the other side. So we're going to have x minus 3 all squared plus y plus 5 all squared. And then if I move this to the other side, I'm going to move the 34 over first, the negative 34. So it becomes positive 34, and then take away k. Now we've got this in the form of the general formula for a circle. So we can see quite clearly that the center of C is going to be minus 3 is going to be a 3 here, and we've got plus 5 that's going to flip to a minus 5. So the center is just going to be 3 negative 5, and that will give you the 2 marks. Now part B says, given that C does not cut or touch the x-axis, find the range of possible values for k for 3 marks. Okay, so whenever I'm doing these types of questions, I always like to visualize them because I need to see what's going on. So what I'm going to do is I'm going to attempt to sketch this circle here. So I'm going to put a get axis like this, and the center is at 3 minus 5. So let's just say, for example, I don't know, let's just say 3 is here, and let's just say minus 5 is maybe down there, for example, like that. The center is going to be over here, right? Now, we don't know the radius, right? It's in terms of k, but what I'm going to do, I'm going to write r squared, isn't it, right? Because it's basically x minus a squared plus y minus b squared is equal to r squared, right? So I can just say that r squared is going to equal 34 minus k. So the radius, which is going to be positive, is going to be the positive of 34 minus k. So in terms of k, the radius is 30, the square root of 34 minus k. And we know from the question that the circle does not cut or touch the x-axis. The x-axis is over here, isn't it? Yeah? Let me put this, label this y as well. So if I was to just get a circle going, let me just draw a circle around it like this, like that, for example, right? That's a circle which has a center of 3 minus 5 and it doesn't touch or cut the x-axis. But let's say it did touch it at least, right? But what would that mean? Well, if I was to enlarge this, now it didn't say it can't touch the y-axis, so I'm going to enlarge this. I'm just going to put this here. So that's a circle that still doesn't touch the x-axis. I'm going to make it a bit bigger so we get to the very boundary, right? So if I do that, and I think that looks to be okay. Yeah, something like that, right? This is a circle whereby the circle touches the x-axis. Now, what you want to ask is, remember the questions ask you to find out the range of values of k, the possible range of values for k. Well, what would the radius be for this to happen? Well, if you think about it, the radius is going to be this distance here, isn't it? Right? It's going to be that distance there, that vertical distance there. And we know that this here is minus 5, right? We can see that this distance here is going to be 5 units, and this distance here is going to be 5 units, right? So when it touches the x-axis, the radius is 5. So we don't want that to happen. So we can see just by looking at the picture, the biggest the radius can be is when the radius is 5. The biggest the circle can be, sorry, is when the radius is 5. You need to ask yourself, well, what value of k does that happen for? Well, that goes back to our expression for the radius. We know that the radius, algebraically speaking, is the square root of 34 minus k. So what I'm going to do here is say that, well, this radius, which is the square root of 34 minus k, if I make it equal to 5, that will give me the value for k for which the radius is 5, isn't it? So working this out, I'm going to square both sides. I'm going to have 34 minus k is going to equal 25. And then if I move that over, 34 minus 25 is going to equal k. That's just going to be 9, isn't it? So we could say that k is equal to 9. Right? So that is one part of it, right? The circle at its very biggest, right, when the radius is 5, gives us a value of k being 9. So we know that k can't be 9. Yeah. And if we just look at the picture, we know this is the biggest it can be. We need the circle now to become smaller and smaller, right, to get the range of values, right? So we know at the very biggest, the radius was 5. Well, at the very smallest, right, what must the radius be? Well, you could have no circle and the radius would be 0, wouldn't it? Right? Obviously, we can't have 0, so that's not going to be included, but that's a critical value as well. So what we want to ask ourselves, let me just get this here, is, well, what value of k will give us a radius of 0, right? Well, again, the radius is equal to the square root of 34 minus k. So let's make it equal to 0, right? To be fair, this is quite easy, isn't it? If I make it equal to 0, square both sides, it's going to be 34 minus k is equal to 0. That means that k is equal to 0 here. So k is equal to 34, sorry. If I move the minus k over, I'm going to get k is equal to 34, right? So we know that when the circle is at its very smallest, when the radius is 0, k is 34. We know that it needs to range. So what I'm going to do here, I'm just going to say, I'm going to just put a very small circle here. Let's just say that this circle is basically nothing, right? I'm just going to say that this one here is when the radius is 0, right? And that represents k is equal to 34, doesn't it? Now, if I copy this circle, let me copy it and then make it very big. Put this here, and I'm just going to make it very, very big. So it's like, whoops, that's the squiggly line. Let me just get a circle, actually. Let me just get a circle. Like that. No, that's not a circle, that's an ellipse. Let me get a circle. Yeah, that's a circle. And then at the very biggest, right, that we know it can be, the radius was 5. So let me just put this like that there. Yeah, that looks fine. The radius is 5 here. Put this here. The radius is 5 here, right? And we know that that value, let me put this here actually. Whoops. There. Uh, put this on top here. The radius is 5 here, the red circle, right? And we know that the value of k for when that happens is when it's equal to 9. So you can see quite clearly. Let me put this as red as well, just so it's super clear. We'll put these two as red, so it's clear. So the red circle is when r is equal to 5, k is equal to 9. I'll put that in a box like that. And when the circle is very small, when there's no circle, essentially r equals 0, the radius, and that gives us a value of k being 34. So we can see quite clearly that the possible values for k must be between 9 and 34, because at the very smallest, when there's no circle, the radius is 0. That gives us k is 34. When at its very biggest, when it touches the x-axis, the radius was 5, and that was a value of k being 9. So therefore, your final answer, I'll do it here. Therefore, your final answer is going to be k being in between 9 and 34. And that will be it. And that will give you all of the marks. And that's question 6. Finished. Okay, so question 7 says the distance a particular car can travel in a journey starting with a full tank of fuel was investigated. From a full tank of fuel, 40 liters remained in the car's fuel tank after the car had traveled 80 kilometers. From a full tank of fuel, 25 liters remained in the car's fuel tank after the car had traveled 200 kilometers. Using a linear model with V liters being the volume of fuel remaining in the car's fuel tank and D kilometers being the distance the car had traveled, find an equation linking V with D for 4 marks. Okay, so this is a typical linear modeling question, right? Part A tells us we need to find an equation linking V and D, which is going to be a linear equation, right? So that means it's going to be in the form of y equals mx plus c, isn't it? So what I'm going to do is I'm actually just going to screenshot these 2 bullet points here, because this is the information that's important. So let me just put this out. Put this over here. Okay, so we need these two. And what do we know? We're dealing with 2 variables, d and v. So let me get axes going as well. So I'll just do one like this, for example, like that. Now, what is going to be our x and what is going to be our y? Remember, y depends on x. X is the independent variable and y is the dependent variable. We're dealing with 2 variables, v and d, v being volume and d being the distance. The volume of fuel is V, right? That depends on how far you travel, isn't it? The further you travel, the less fuel you're going to have. So definitely V is going to be our Y, the variable that depends on our distance. So I'm going to put this here. It's just always something to do. So we're just going to say then that this is going to be our X, this is going to be our Y. So D and V. Now let's use those bullet points. It says from a full tank of fuel, 40 liters remained in the car after traveling 80 kilometers. So what I'm going to say is that we have the first coordinate to be 80 for D, 80 kilometers, and 40 liters. So we've got that there. And the second pair is going to be 200 for D and 25 for V. Now we need to find an equation for this model. Remember, generally it's going to be y equals mx plus c, but we're not dealing with y and x. We're dealing with v and d. So it's going to be v is equal to m and then d plus c. Now, how do we do this? Well, firstly, we can figure out what the gradient is, can't we? Because we've got 2 coordinates here. So I'm going to say m from here is just going to equal y2 minus y1 of x2 minus x1. So it's going to be 25 take away 40 divided by 200 take away 80, isn't it? Like that. So I'll just put this into the calculator. Let's see what I get. That's going to be 25 take away 40 over 200 take away 80. This gives me minus an eighth. So I know the gradient of our line, so I'm going to update it and say, I'll do it here. I'm going to say V is equal to minus an eighth D plus C. Now, how do we get our y-intercept? Well, or our v-intercept, I should say, is we're just going to plug in any one of these 2 coordinates, aren't we? I'll do the first one. So I'll plug in the first one, which is going to be, let me write this again. So V is going to equal minus an eighth D plus C. And I'm going to use the first pair of coordinates, which is 80 and 40. 80 and 40. Plugging that in is going to give me 40 will equal minus an eighth and then 80 here plus C, and then that would be 40 is equal to an eighth of 80 is just going to be 10 now, so minus 10 plus C. That gives us that C is equal to 50, isn't it? meaning that our complete model is going to be V is equal to minus an eighth D plus 50. And that will give us the 4 marks for part A. Now, part B, what does part B say? It says, given that on a particular journey, the fuel tank of the car was initially full, the car continued until it ran out of fuel. Find, according to the model, the initial volume of the fuel that was in the fuel tank of the car and the distance that the car traveled on this journey for 3 marks. So let me screenshot that as well. So we don't need to keep going up and down. And I'll put this here. Okay. Let me paste this here. All right. So this is the information given to us. And we know the general model is that one over there. V is equal to minus an eighth D plus 50. And the first bullet point tells us that the fuel tank of the car was initially full, right? Initially full. Well, if you think of that word initially, right, that means at the start. We know we're dealing with the distance traveled and the volume of fuel. At the start, you haven't traveled anywhere. So this implies here that D is 0. Yeah, so I can use this to calculate what V is, and this is the initial volume. So I'm gonna say for I know that D is gonna be 0, so I'm gonna say V is gonna equal minus an eighth times 0 plus 50. So that just means that V is equal to 50. So therefore, the initial volume of fuel is just 50 liters. So I'm gonna say initial volume is equal to 50 liters. Okay, now B double I asks us to find the distance the car traveled on this journey. Well, we know that the car continued until it ran out of fuel. It started with 50 liters. If you run out of fuel, you're gonna have no liters left, which implies that this one here, V must equal 0. Yeah. So what we can do now is just plug in V for 0 into our linear model to figure out the value of D. So I'm going to do this here. So that would be 0 will equal minus an eighth D plus 50. That tidying this up is going to be an eighth D is equal to 50 times both sides by 8. This will give us 5 times 8 is 40. So 50 times 8 will be 400, isn't it? So it'll be 400 kilometers. So that must be how far the car traveled until it ran out of fuel. So that is done. That is part B, I, and double I. Now, there was one more part to this question. It said, in fact, the car traveled 320 kilometers on this journey. Evaluate the model in light of this information for 1 mark. Okay. So remember what you're doing with these types of questions. This is a modeling question. You're modeling a scenario, right? We're using linear equations to model some sort of scenario that's happened in real life. And the fact of the matter is that the car traveled 420 kilometers, right? Ran out of fuel, 420 kilometers. Now, what I'm going to do, I always write this down. I'm going to say fact. The fact of the matter is that the distance traveled 320 kilometers. And this is when V is equal to 0, isn't it? Yeah? Because it ran out of fuel. Now, our model tells us, right? I'm going to say our model tells us that when the distance was 400 kilometers, that's when it ran out of fuel. So we just need to compare these two, right? 320 and 400, these are quite different, right? They're not very close together. So what you're going to say is that, what was the fact? Yeah. So 400 kilometers, which is what our model tells us, right? Is quite far off 320 kilometers, right? So therefore, all right, therefore triangle, therefore the model is not suitable. That's it. That will give you the 1 mark for the end of this question. And yeah, we're finished. Okay, so question 8 says figure 3 shows a sketch of a curve C and a straight line L. Given that C has equation y equals f of x, where f of x is a quadratic expression in x, C cuts the x-axis at 0 and 6. L cuts the y-axis at 60 and intersects C at the point 1080. Use inequalities to define the region R shown shaded in figure 3 for 5 marks. Okay, so if I'm doing this question, what I would do is, well, if I'm looking at the graph, the region R I can see is bounded by the line at the top and by the quadratic at the bottom, isn't it? So what I would do is I'll just define the region R just in terms of what I can see. Yeah. So I'm gonna say that the region R at its lowest, it's bounded by the quadratic, which we don't know, but it's called f of x. So I'm gonna say f of x, right? And then I'm gonna say this is less than or equal to because it's inclusive. I'm gonna put y here. And then at the highest, it's bounded by the line, isn't it? Which is called the line L at the moment. So I'm going to just put line L here. So this is our answer. Obviously, we need to figure out what the quadratic is and what the line is, and then we're done. So let's start. Let's do the line, right? Because that's easier anyway. So what do we know about the line? We can see quite clearly that it has an intercept of 60, right? So what I'm going to do is say, okay, for the line L, for the line L, we've got y equals mx plus c. And we know the y-intercept is at 60. So I'm going to update this to say y is equal to mx plus 60 so far. Now we need the gradient. Well, how can we figure out what the gradient is? Well, we've got 2 points on that line. We've got the point 060, the y-intercept, and we've got the point 1080. So I can just use changing y over changing x to figure out what the gradient is. So I'm going to just do this here. So I'm going to say 2 points on that line. 2 points are going to be 060. That's the y-intercept. And the other one was 1080, wasn't it? So what I'm going to do is just going to do y2 minus y1. So it's going to be 80 take away 60 divided by 10 take away 0, which is 20 over 10, which is 2. So therefore, the gradient of the line L was 2. So that means that the equation of the line L was just y is equal to 2x plus 60. So that's the line L done. Now we need to figure out what f of x is the quadratic. Now, what do we know about the quadratic? It says C has equation f of x quadratic. C, which is the quadratic, cuts the x-axis at 0,6, which you can see quite clearly. Now, if I look at this quadratic here, we can see that it has 2 roots, right? One at 0, one at 6. So remember when you're factorizing, if I get a 0 and a 6 out, that would mean that, for example, I'd be solving a quadratic whereby I have x, which will make 0, or it would be x minus 6, isn't it? And this will be equal to 0. And this will give me 2 roots, x equals 0, or x is equal to positive 6, isn't it? All right, so you could say that the graph, this function here, definitely has x minus 6, right? However, that's not all you can say because there are many graphs, and in fact, an infinite amount of graphs which will have those same roots as well. So I'll just show you. For example, this is the graph here. Imagine this was x minus 6. It may not be, it may be, but there would also be a graph, a quadratic, that has those same 2 roots, which is a lot steeper, like that, right? Or you could have another quadratic, which has those same 2 roots, which is a bit flatter as well, like that. Right? How do we account for all of these different stretches? Well, this is just a graph transformation, isn't it? And it's the graph transformations where the multiply means that you vertically stretch the graph, right? So essentially what you're going to be doing is saying that you've got this graph. I'm gonna call f of x, which is the quadratic. I'm gonna call it x minus 6. However, we don't know what the multiplier is because it could be any one of these three or any more, and that is accounted for by putting a here, and this just indicates that we can have a stretcher, right? And obviously to figure out what that multiplier is, we need a coordinate, don't we? Which we do have, which is 1080, right? So gonna use that one. So this is our graph here. We know that 1080 passes through. So if I punch this in, this will give me 80 is equal to, and then it will be a bracket 10 and then 10 minus 6, isn't it? Like that. And then what's that? That's going to be 80 is equal to a and then 10 and then 4, which is 40, isn't it? So we get 80 is equal to 40a, which means that a has to equal 2, doesn't it? So we now know the multiplier. We now know that it's just stretched vertically by a scale factor of 2, right? So that means our function for the quadratic, I'll just finish it off here. F of x will equal 2 and then x minus 6. That will be our quadratic. Now we've got the quadratic, we've got the line L, we can just finish this question off by writing inequality. So put this here, paste this here. So therefore the answer for the region defined, right, is going to be 2 and then x minus 6, and then less than equal to y, and then less than equal to the line L, which was 2x plus 60, isn't it? And that's it, and that will give you the 5 marks, and that's question 8 finished. Okay, so question 9 says, using laws of logarithms, solve the equation 2 log with base 5 of 3x minus 2 minus log base 5 of x is equal to 2 for 5 marks. Now, firstly, what you always want to do, especially when you're dealing with these types of questions here, is have a look at the arguments of your logs, right? So we know that logs themselves, the arguments have to be more than 0, right? So when I look at these, firstly, I can say from there, x has to be greater than 0, right? For you to be able to plug in a number into that. For this one, you're going to say 3x minus 2 has to be greater than 0, isn't it? Which would mean that 3x has to be greater than 2, which means x has to be greater than 2 over 3. So basically 0.6 recurring. So that is what I'm going to put here. And you should have that in mind once you get your solutions. So let's go ahead and actually solve this now. We've got 2 with log base 5 over 3x minus 2 minus log base 5 of x. This is equal to 2. Now, firstly, we've got the power rule for logs, which means that that 2 can go to the power. So it becomes log base 5 of 3x minus 2 all squared minus log base 5 of x is equal to 2. Now, we can divide them because we can use the subtraction law for logs to say that we've got log of base 5, and then this just becomes 3x minus 2 all squared divided by x, and this has to equal 2, right? Okay, now, when you're here, what I like to do, remember, we're trying to solve for x. I want to get rid of this log. Because the base is 5, I'm going to put these both with a base of 5. So I'm going to do this like that and do this like that. And what happens essentially is that that 5 will cancel with that log 5, and I'm just left with this. And obviously that's just 5 squared. So basically what we're going to have then is we're going to have 3x minus 2 all squared over x is equal to 5 squared, isn't it? Which is just 25. And then now this is just a quadratic, isn't it? We need to expand and simplify, blah, blah, blah. So let me expand the numerator. So if I expand that numerator, you can do double brackets and expand, but I'll do it very quickly. 3x all squared is going to be 9x squared. And then we've got 3x times the minus 2, which is minus 6. And then we have to double that to give minus 12x. And then minus 2 all squared is plus 4. So we get that there. And then this is all over x, and then this is equal to 25. Again, this is just me doing it quickly. You can just do 3x minus 2, 3x minus 2, use the Fourier method and expand, you get the same thing. Anyways, continuing, I'm gonna times 3 by x, so I'm gonna have 9x squared minus 12x plus 4 is gonna equal 25x, isn't it? Like that. And then now I'm going to move everything from right to left to get it in the form x squared plus bx plus c is equal to 0. So 9x squared, and it's going to be minus 12x minus the 25x plus 4 is equal to 0. Tidying this up, I'm going to get 9x squared minus, what's that, 37x plus 4 is equal to 0. So we're here. We can use our calculator now just to solve this. So I'm going to get my calculator and solve this. It's going to give me, remove this here. It's going to be, gonna go to equation, 2 polynomial, 2 degree. A is 9, B is negative 37, and C is 4. So one answer I get for x is equal to 4. And is there another answer? 1 over 9, which is 0.1 recurring, isn't it? So x is equal to 1/9. All right, so we've got these two answers. Now remember what we did at the very beginning before we even did any algebra. We looked at the arguments. Now, we know that x has to be positive, greater than 0. Also has to be greater than 2 over 3. Right, so based on what we have, are any of these not satisfied? Well, this one is fine, x equals 4, because that is greater than 0 and it's greater than 2 over 3. But this one, 1 over 9, right? That's 0.1 recurring. It's smaller than 2 over 3, isn't it? So we can't use this one. So we're going to reject this solution. Reject solution, right? As 1 over 9 is smaller than 2 over 3. So therefore, you can say that your final answer is just x is equal to 4. And that's it. Finished. Okay, so question 10 says, the line L1 has equation y is equal to 3/5 x plus 6. The line L2 is perpendicular to L1 and passes through the point B80 as shown in the sketch in figure 4. Part A says show that an equation for line L2 is 5x plus 3y is equal to 40 for 3 marks. Okay, so this isn't too bad. So line L2, we know is perpendicular to L1, so it's going to have the negative reciprocal gradient, and we also know point of passes through, so it's very easy actually, to be fair. So just going to do part A here. Now, L2, right now it's y equals mx plus c. That's all we know. We know that it's perpendicular to L1. The gradient of L1 is 3 over 5, isn't it? So the perpendicular gradient, I'll just write perp here. Perp. Sorry, that's awful spelling. Handwriting, I should say. I know how to spell. Perp is going to equal negative 5/3, isn't it? So therefore, I can say we have y is equal to minus 5 over 3x plus c so far. And we also know the point B passes through this line that we're looking for, which is 80. So we could just punch that in, can't we? So I'm just going to say B, which is 80. If I punch that in there, it's going to be 0 will equal minus 5 over 3x, which is 8, plus C. And it's going to be 0 is equal to 5 times 8 is 40, negative 40 over 3, plus C. So therefore, C is equal to 40/3. Okay, meaning that our equation is y is equal to minus 5 over 3x plus 40 over 3. Now, that's not the form that they wanted it in. They wanted it with integers as coefficients. So we need to times by 3. So we're going to have 3y is equal to minus 5x plus 40 if I times everything by 3. And then obviously that means we can move the minus 5x over to the left. So it becomes 5x plus 3y is equal to 40 as required. And that will give us the 3 marks for part A. Now part B says, given that L1 and L2 intersect at the point C, the line L1 crosses the x-axis at the point A. Find the exact area of triangle ABC, given your answer as a fully simplified fraction in the form P over Q for 5 marks. Okay, so what I'm going to do is I'm going to grab this part and put it underneath here. And I'm also going to get the diagram as well, just so we don't need to keep going up and down and we can just refer to it. So I'm going to put that there. And then the diagram is here, isn't it? So let me grab that as well. Okay, cool. So that's all we need, isn't it? Oh yeah, we need the equation of the lines as well, which I'll go and get in a sec. But anyways, we need the area of triangle ABC. Now, for me, let's plug in everything that we know. We know that this point B here, by the way, was 80. So I'm just going to put an 8 here. I think that was it actually. Obviously, we know the equations of the lines. L2 was that one. And then L1 was 3 over 5x plus 6, isn't it? So I'm going to put this here. Y L1. This one was here. This was y is equal to 3 over 5x plus 6. And then this one was 5x plus 3y is equal to 40, if I'm not mistaken. Yeah, it was. Yeah, perfect. Okay, so we need to find the area of the triangle. Now, the triangle here, we can see it is made by the x-axis, isn't it? So what I would do is, essentially, I'm just going to draw a triangle again. I'll do it here. Things look something like that, isn't it? To answer the question, I would want to work out what this here is, this vertical height here, right? Or yeah, it's vertical, and this distance here, right? So I'm going to just say height. I'm going to say this is the base here at the bottom. And obviously the area is just going to be half times base times height. So if I can work out what these two are, then that should be fine. Now, how do I work out what those are? If I look at the picture though, this is the point C here, where I can get that vertical height, right? But I would need to know what the coordinates of that point is. That's the first thing. So I would need to work out the point of intersection of L1 and L2 because that's what the point C is, isn't it? So I need to do that. I've got these two equations. So I'll just write them out again. It's going to be 5x plus 3y is equal to 40. That's one equation. And the other equation is y is equal to 3 over 5x plus 6. Now, if I want to solve that simultaneously, because we have two equations, I can just punch this equation, right, into there, couldn't I? So that would mean that I'm going to have 5x plus 3 lots of y, which is 3/5 x plus 6, x plus 6, and this has to equal 40. So tidying this up, this will give me 5x plus, expanding that is going to be 9 over 5 x, and then 3 times 6 is 18. This is equal 40. And then 5 plus 9 over 5. 5 is the same as 25 fifths. 25 over 5. 25 plus 9 is 34. So this is 34 over 5x. You could always punch this into your calculator as well. And then plus 18 is equal to 40. Take the 18 over. I'm going to get 34 over 5x is going to equal 22. So I get that, and then that would mean that x will equal, let me just double check that's correct. Yeah, that's fine, because 22 plus 18 is 40. X is going to equal 22 divided by 34 over 5, isn't it? So I'll put it into my calculator and see what that gets me to when I simplify it. So it's going to be 22 over 34 over 5. And that gets me 55 over 17. So the x coordinate of the point of intersection, C, is 55 over 17. But I want the y coordinate, don't I? Because that would be the height of the triangle. So I'm going to plug x into one of these equations here. It's easier to plug it into this one. So I'm going to do that there. So that would mean that y is going to equal 3/5 of x, which is 55 over 17, plus 6. So I'll plug that in and see what that gives me. So that will be, I've got that stored already, so I need to write it out again. I'm going to write 3 over 5, and then times my answer, plus 6. That gives me 135 over 17. 135 over 17. So let's just see what that looks like geometrically. If I zoom in here, um, the x coordinate was 55 over 17. We now know the y coordinate was, what was it again? 135 over 17. Yeah. And that just translates to this height here. Yeah. So I'm going to just write 135 over 17 here, because we now know that is the height of the triangle, 135 over 17. So now all we need to do is figure out what the base is. And I think that's actually easier, to be fair. But anyways, the base would be from A to B. I know what this point B is. It has an x coordinate of A. I need A. Well, that's just going to be the x-intercept, isn't it? Where y is 0 of the line L1. So we need that. We need the x-intercept of L1. So we're going to plug in 0 to figure out what that is. So line L1, right? L1 was y is equal to 3/5 x plus 6. Yeah. To figure out what that point A is, it was A, wasn't it? Yeah, it's point A. We need to plug in y is 0. So I'm going to set y equal to 0 to find A. And that will give me 0 is equal to 3 over 5x plus 6. That would mean that I'm going to have, move that over, minus 6 is equal to 3 over 5x times by 5 minus 30 is equal to 3x, divided by 3, x is equal to minus 10, isn't it? So therefore, the point A just has an x coordinate of negative 10. Let me do it in red as well, so it's super clear. That's going to be right here. It's going to be minus 10, meaning that, well, from minus 10 to 8, minus 10 is over there, 8 is there. The base is going to be 18, isn't it? So I'm going to put 18 here, like that, put in a bracket. So now, the answer was to figure out what the area of the triangle is. The area is just going to be half times base times height. So where should I do it? You know what, I'll just bring this here just so it's all in a nice order. So I'm going to copy this and bring this here and just finish it off here. Why not? Okay. So therefore, the area for the triangle ABC, area is going to equal 1/2 times the base, which is 18, times the height, which is 135 over 17. So I'm going to plug this into my calculator and see what it gives me. 1/2 times 18 times 135 over 17. Oops. And that equals 1215 over 17, which is in the form of P over Q. So that is going to be our answer. Does it say I need to state it or anything like that? No, that's fine. So yeah, that will be part B, and that will give you the 5 marks for it. And that's question 10 finished. Okay, so question 11 says the height h meters of a plant t years after it was first measured is modeled by the equation h is equal to 2.3 minus 1.7 e to the minus 0.2 t, where t is element of the rows, t is greater than or equal to 0. Using the model for part A, find the height of the plant when it was first measured for 2 marks. So this is very, very easy. When it was first measured, that just means initially, and that just means when t is equal to 0. So what you're going to do for part A is just plug in t equals 0 into that formula here. It's going to be 2.3 and then minus 1.7 e to the minus 0.20. Uh, you can plug this into a calculator, but I'll just do it like this. That's going to be 1.7 e to the 0, right? Anything to the 0 is 1. So it's just 2.3 take away 1.7, which is just 0.6. So the height when it was first measured is going to be 0.6 meters. So I'll put that there, 0.6 meters, because h is in meters. Okay. Part B says, show that exactly 4 years after it was first measured, the plant was growing at approximately 15.3 centimeters per year. Now, this one's 3 marks. Is very sneaky because you may be thinking to just plug in 4 into your H and see if you get 50.3, but you won't, because firstly, you don't do that because it says per year, right? So that's the rate at which it's growing at. And secondly, you wouldn't get anyway because this is in meters. This is in centimeters and the question is in meters. So there's a couple of things there, but you'd maybe try it that way and then you'd figure out that it doesn't work that way. But anyways, main thing here is that it's sneaky because it doesn't say the word rate. With these questions, it normally says growing at a rate. And that word rate, which is missing from this question, but it's implied, just means dy dx. So you just differentiate. So what you're going to do is you're going to differentiate h and then you're going to plug in 4 into that. And then hopefully we should get what they want. So I'm going to write out the equation again. So h is equal to 2.3 minus 1.7 e to the minus 0.2t. Now differentiating that, dh by dt, that will equal, that's going to disappear. Now remember, this is an exponential one. Remember, if I've got e to the kx, this differentiates to k e to the kx, doesn't it? Right? Let me just write d dx here. Yeah. So in this case, we've got minus 1.7. That's a constant. The minus 0.2 is going to drop to the front, which is going to be minus 0.2, and it's going to be e to the minus 0.2t, isn't it? So that means dh by dt will equal, and I'll just punch this into my calculator just to see what it simplifies to. I'm going to do minus 1.7, even though I don't need the minuses, but anyways, minus 1.7 times minus 0.2. I could have done it without the minuses, but I'll just do it just to be thorough. 17 over 50. So I've got 17 over 50 e to the negative 0.2t. Okay, now I'm going to plug in t equals 4 into that. So if I plug in 4 into there, it's going to be 17 over 50 e to the minus 0.2 and then times by 4, right? And this is going to tell me the rate at which it's growing at after 4 years, isn't it? Because I'm dealing with the gradient function. So plugging that in, it's going to give me 17 over 50, and it's going to be e to the power of minus 0.2 times by 4, and that gives me 0.15, what was it? 2277 blah blah blah. Remember, this is in meters now, isn't it? Because remember, h is in meters, so this is going to be meters per year. So if I want it in centimeters, which is what they asked us for, we're going to just times by 100, isn't it, to get in centimeters. So if I times that by 100, that's going to be 15.277 blah blah blah, which is the same as 15.3 centimeters per year. So that's it. And that gives us the answer for part B, and that's 3 marks. Now, part C says, I'll do it here. Part C says, according to the model, there is a limit to the height to which this plant can grow. Deduce the value of this limit. So the height of this plant is determined by this formula here, and it's an exponential one. What you notice is that the power of the exponent is negative, which means it's going to be exponential decay, isn't it, or decreasing. So what you want to do is you're just going to punch in a really, really big number to find out what the limit is, right? So the function is h is equal to 2.3 minus 1.7 e to the minus 0.2t, and I'm going to get my calculator. We're just going to investigate what happens as t gets large. So we've got 2.3 minus 1.7. It's going to be e to the minus 0.2. Now let's just say I've made t10. What happens? Becomes 2.06. Let's say I made it 15. Becomes 2.21. Right? Let's say I made it 150. 23 over 10, 2.3. Let's say I made it 1,500. Like that. You can see it's 23 over 10, 2.3. So as t gets really big, as t tends to infinity, right? H tends to 2.3, sorry. Yeah. So the limit is just going to be 2.3. So you're just going to say limit is equal to 2.3. Yep. So you can do it that way. You could also sketch the graph, but you don't need to. But yeah, another thing as well that I could mention, why not, is algebraically, if you look at the function here, we've got 2.3, and then I've got minus 1.7, and then from my index source, I can write this as a fraction, isn't it? It's going to be e to the 0.2 t, like that. Now, if t gets really, really big, then the denominator is going to get really, really big as well, because it's an exponential one as well. So if t gets really, really big, I'm just going to write, let me write lim as t goes to infinity, right? Of that, what will happen is essentially you're going to have 2.3 minus 1.7 over e to the infinity, right? And e to the infinity is just going to be an even bigger infinity. It's just going to be a very, very big number, essentially. So what will happen, we've got 2.3 minus 1.7 over infinity. So that's a really, really big number, which means that I'm dividing by a very big number. This is going to go very, very small. It's going to basically be 0, isn't it? So it's going to be 2.3 minus 0, which is 2.3. So you could have done it like that as well. But either way, whatever way you prefer is fine. But yeah, that's pretty much it, and that will give you the full marks for this question. Okay, so question 12 says, show that the equation 4 tan x is equal to 5 cos x can be written as 5 sine squared x plus 4 sine x minus 5 is equal to 0 for 3 marks. Okay, so let me just write out again. So we got 4 tan x is equal to 5 cos x, and it's a show that question, and we're dealing with trigonometric identities. Now, in AS, you only know two. You only learn two. Sine squared plus cos squared is equal to 1, and sine over cosine is equal to tan. Now, based on what we have, we've got a tan x here. So firstly, what I would do is rewrite that as tan. So I'll rewrite that as sine over cos, sorry. So it becomes 4 times by sine over cosine, sine x over cos x. This has to equal 5 cos x. That's the first thing. Now, because remember, you're dealing with a show that question. Have a look at your show that it's all in terms of sine. So what you want to do is get everything in terms of sine. We've created a sine, right, from the sine over cosine. So this is good progress. Now, what I would do next is we've got a fraction there. Let's multiply 3 by the denominator. So we're going to have 4 sine x is equal to 5 cos squared x, isn't it? Now, from our identity, we should know that cos squared x is equal to 1 minus sine squared x, isn't it? Just from sine squared plus cos squared is equal to 1 by rearranging. So what I can do is say, well, 4 sine x is equal to 5, and then it's going to be 1 minus sine squared x. And this is good because now it's all in terms of sine, which is what we want. So now we can just expand and simplify. So we're going to have 4 sine x is equal to 5 minus 5 sine squared x. Now, if I move everything from right to left, I'm going to have a positive 5 sine squared x. I have that 4 sine x go in the middle, and then I'm going to take the 5 away. This is equal to 0. This is exactly what they wanted, so that will give us the 3 marks. So that's done. Part B says, hence solve for x between 0 and 360. 4 tan x is equal to 5 cos x. Give your answer to one decimal place for 4 marks. Okay, so we need to solve this equation. In part A, we show that this equation can be written as this equation. So the solutions to this equation here is the exact same as the solutions to that equation there, because they're the same thing, just in different forms. So I'm going to solve that one because that's something we're familiar with. It's a quadratic, isn't it? So for part B, I'm going to solve this again. So let me just copy it and write it out again. So this is a quadratic, as we can see. But if it's not clear, what you can do, let's paste this here. It's a quadratic, but if it isn't clear, what you can do is you can say, well, you can say let u equal sine x. And well, that means that will become 5u squared plus 4u minus 5 is equal to 0. And that is super clear now, isn't it? Now, what I'm going to do is I'm going to just solve this with my calculator just to get the roots. So I'll get my calculator up. I'll do another page. It's going to be, where are we? I'm going to go to shift Now, so I'm going to go to menu. I'm going to go here, equals, and then polynomial 2. It's going to be 5. It's going to be a 4. It's going to be a -5 here. Like that. And that will give us one value for u anyway. It's going to be -2 plus √29 over 5. And the other one's going to be minus, isn't it? Yeah, minus. So it's going to be plus or minus uh, -2 plus or minus √29 over 5. And that's equal to u. But remember, u is a substitution. We need to bring it back to sin x. So I'm just going to say sin x is equal to all of that. Plus or minus √29 over 5. Now let's have a look, because remember, and also I need to bring this here. Sin x we know oscillates between 1 and -1. So let's just check to see if any of these cause us an issue. That one does, doesn't it? The negative version, the negative solution is -1.4, right? That's going to be outside the range. And you'll know because if you try and do sine inverse of it, it won't work. So we're not going to use the negative solution, right? So we're just going to say -2 minus √29 over 5, right? Is less than -1, right? It's outside the range for where sine is valid. So there's going to be no solutions here. No solutions for that one. So the only equation we're going to be solving is sin x is equal to -2 plus √29 over 5. Obviously, just double check what it is. Obviously, there has to be one solution, but might as well just check just to be safe. Yeah, 0.677. So that's fine. So now what I'm going to do, remember we're solving it between 0 and 360. So I'm going to take the sine inverse now. So I'm going to have x is equal to the sine inverse of all of that. -2 plus √29 over 5. And see what that gives me. Go back here. Does it keep it? No, it doesn't. I'm going to do sine inverse of -2 plus √29 over 5. And that gives me 42.6, doesn't it? 42.61, blah, blah, blah. But it did say to one decimal place, doesn't it? So, yeah, it did. So 42.6 is one solution. And then the other one, remember sine, you can use the cast method, you can use your graph, or you can just memorize. Remember, if I've got sine x here, this is just equal to 180 minus x, isn't it? So all you're going to do is just do 180 take away that answer there to get the other one. So it's going to be 180 take away answer. And that gives me 137.38, which is 137.4. So the other answer is 137.4. And it's between 0 and 360. There's not going to be any more because the next one we're going to have to add 360 to that one. So these are going to be the two answers for part B. So that's done. Now part C says for 2 marks, just put this here. Hence find the number of solutions of the equation 4 tan 3x is equal to 5 cos 3x in interval 0 to 1 to 0 to 1800 degrees. Explain briefly the reason for your answer. Okay, so I'll do it here. Okay. So this one, what do we have? What do we have? We have to solve, we need to find how many solutions there are. So when we solved this one, the one above, which was 4 tan x and equals to 5 cos x, right? So we had 4 tan x is equal to 5 cos x, right? What we figured out is that the number of solutions were 2. There were 2 solutions here, yeah, between 0 and 360. And remember, what we solved essentially is sin x. When we did the algebra, we got just sin x is equal to -2 plus √29 over 5. And there were 2 solutions to this equation. So what I like to do when I'm doing these type of questions is this. I've got 2 solutions here. All right, 2 solutions between 0 and 360. So I'm going to write 0 here, x, and 360, right? This was when we had sin x, yeah? Now, the moment this is a 3x, right, you can just imagine that all of the algebra will be the same. The only difference is that the argument, the angle is going to be a 3x now instead of an x. And what will happen, though, right, is I'm going to put sine 3x here. What will happen is, remember, think of the graph of sin x. If I put a 3, it's going to just compress horizontally by a scale factor of 3. So everything is just going to divide by 3. So there's going to be 3 times as many waves, right? Which means there's going to be 3 times as many solutions, isn't it? So when it's sine 3x, between 0 and 360, like that, there would be 3 times as many solutions because there's 3 times as many waves, right? So I'm going to times this by 3. That means I'm going to have 6 solutions, right? Between 0 and 360. Yeah. Now, the question didn't ask for 0 to 360. It asked for 0 to 1,800, right? So we know that in one period, right, when we have a sine 3x, right? Let me highlight in green so it's super clear. We have 6 solutions. But remember, we need it between 0 and 1,800. Well, you need to ask yourself, how many cycles are there from here to here? Well, how many times does 360 go into 1,800? Let's check. 1,800 over 360 is 5, right? So I'm gonna times by 5 here. There's gonna be 5 cycles, right, of this hair. So therefore, we're gonna times the amount of solutions by 5. 6 times 5 is 30. So therefore, there will be 30 solutions. And that's it. And that will give all the marks for this question. Okay, so question 13 says, relative to a fixed origin O, point A has position vector 10i minus 3j, point B has position vector minus 8i plus 9j. Point C has position vector minus 2i plus pj, where p is a constant. Part A says we need to find the vector A to B for 2 marks. Okay, so this is very straightforward. So part A, let me just change the thickness of it actually. So part A, AB, we know it's just b minus a, isn't it? And what I'm going to do, I'm just going to write this as a column vector just so it's easier. For me, I personally just prefer column vectors, but the question is in ij form. So once I'm done, I'm going to put in ij to get the marks. So it's going to be b minus a. I'll just write b here and I'll write a here. B minus a. The vector b is minus 8, 9. A is 10 minus 3. So taking these away, this is going to be, all right, a to b. This is going to be equal to minus 8 minus 10 is minus 18. And 9 minus minus 3 is 12, isn't it? 9 plus 3 is 12. So the answer is going to give me minus 18i plus 12j. Right, that is part A done. Remember, I and J form. So part B says find the magnitude of A to B. Give me the answer as a fully simplified surd. So that's easy again. So all that means is we're just going to do the Pythagoras of the two components. So it's going to be equal to the square root of the component for I, which is going to be negative 18. So negative 18 squared plus the component for j, 12 squared. And then I'm just going to put this into my calculator and see what it gives me. So this will give me square root of minus 18 all squared plus 12 squared. And that gives me 6 root 13. Perfect. So that's done. Part C says, given that the points A, B, and C lie on a straight line, find the value of P and state the ratio of the area of triangle AOC to the area of A or B, and it's all the 3 marks. Okay, so what I'd want to do with the question is to visualize this, right? So I've got my 3 points here, position vectors, and there's a fixed origin O, so we can pretty much treat these as coordinates, can't we? So what I'm going to do, I'm going to get an axis going. So I'm going to get an axis going like that. And then I'm going to attempt to plot those points. So point A was 10 minus 3, isn't it? So let's just say 10 is here, for example. Let's say 10 is here. Let's say minus 3 is around there approximately. So let's just say this is the point A, which is going to be 10 minus 3. And then point B was minus 8, positive 9, isn't it? So I'm going to say, let's just say minus 8 would be around here then. Let's say minus 8 is there. Let's say positive 9 is probably, let's just say it's like there, for example. So the point B is going to be here. I'm going to call this point B minus 8, positive 9. And now the point C, we only knew one of the coordinates, minus 2i. So x is minus 2 and y is p. Okay. So if minus 2 would be around here, right? Then that tells us we need to find out what P is. P is definitely going to be positive, isn't it? Because we know that A, B, and C lie on a straight line. So C is closer to A than B is. So it's going to just say approximately, let's just say P is here, for example. It's going to be around here. And if I just draw a point like this, and then I'm going to call this point C, then I draw a line that connects all of them together. I'll do it in red. This is going to be our line, isn't it? Yeah. So we've got that there. And let me just call this C, and I'll call this, what is it, minus 2P. like that, and I'll call this the position point C, and I'll put this in blue as well. Why not? Just to keep it consistent. Okay. Now we need to figure out what P is. Now the reason why I've done this is because it lies on a straight line. We're dealing with vectors, even from GCSE. I've got this vector here, which is going to be A to C, right? We can just see from the diagram that A to C is just going to be some fraction of the entire line, isn't it? Which is going to be A to B, right? So the green line is meant to be representing A to B. The yellow line is going to be representing A to C. So what I can say from this picture here is that the vector A to B, which is the longer one, right, will be equal to some multiple of the yellow one, right? It's just a stretched out version of the yellow line, isn't it? So I'm going to say A to B is equal to lambda and then A to C. And then what I'm going to do now is I'm going to get A to B and A to C, and hopefully I'll be able to figure out what lambda is from there. So A to B we already know it was minus 1812. So what I'm gonna do actually, should I do it? Have I got room here? Yeah, I'll do it here and I'll do it on the rest on the other page. So this vector here, I'll do it in column form again. Minus 1812. 12. This will equal lambda, and then I'm gonna work out what A to C is now. Now A to C is going to be C minus A. So let me do it. Where should I do it? You know what? I'll grab this and actually do it on the other page. Put this on the other page just so there's room. Okay. Now what was A, what was C? So A to C is going to be equal to C minus A. So minus 2 minus 10, isn't it? We'll do minus 2 minus 10. And then it's going to be P minus minus 3, isn't it? P minus minus 3, like that. And so let me just be super clear. So what I've done is I've done the vector C, which was minus 2p. Yep, minus 2p. And I've taken away the vector A, which was 10 minus 3. So you can see that I get that there. And then that's just going to equal, if I tidy all of this up here, that's going to be equal to minus 12. And then P minus minus is a plus, so P plus 3. So this is our expression for the vector A to C here. And I'm going to substitute that into my formula underneath, or my equation, I should say. So minus 12 P plus 3. So I'm going to put this here. Minus 12 and then P plus 3. Now remember, I'm trying to figure out what P is, right? But for P, I need lambda. And I can figure out what lambda is just from the top one. Because if I expand this now, it's going to be minus 18, 12, and then this is going to equal minus 12 lambda, and then it's going to be lambda and then P plus 3, isn't it? Like that. Now these are equal, so I can just equate the components. I can say that minus 18 must equal minus 12 lambda, which would mean that minus 18 over minus 12 is going to equal lambda, meaning that, what's that? 18 over 12 is divide 6, top and bottom, 3 over 2. Yeah, so lambda is going to equal 3 over 2. So in other words, that is the scale factor. That is what we multiply the yellow line by to take us to the green line, 3 over 2. Yeah. Now the reason why we can find P is because now if I use this one, if I equate these two components, it's going to be 12 is equal to lambda and then P plus 3. But we know lambda is 3 over 2, so we can just replace that. So I got 12 is equal to 3 over 2 and then P plus 3, like that. And then I'm going to times by 2, which is going to be 24. And it's going to be 3 bracket P plus 3. Divide by 3, I get 8 is equal to P plus 3. What plus 3 gives me 8 is 5, isn't it? So therefore P is equal to 5. Perfect. So that's done. Now, part double I says state the ratio of the area of the triangle AOC to the area of the triangle AOB. So this one here, again, it's not the trickiest, but it's not as straightforward in my opinion anyway. So let me just get this here. And then I'm just going to grab this question here. And then I'm going to get this diagram again because it's very, very helpful for explaining these types of questions. So I'll copy this here and I'll put this over here. Okay, so I'm gonna just zoom in a bit. Okay, let me rub out the highlighters as well. So we need the ratio of the two triangles AOC and AOB. Now, if I do this here, the point O is obviously going to be the origin, right? So I'm going to put O here, like that. And if I was to do this, and I was to do that, that would be the triangle AOC, isn't it? Like that, right? Now, you know what I'm going to do actually, just to make it very, very easy to see, is I'm just going to draw the exact same two triangles, but I'm going to just flip it so it's just the right way up. So it's just very, very clear to see what I'm doing. So remember, let's just look again. We've got this point O, and point O, or O to A, is going to be on both triangles, isn't it? Because it's AOC and AOB. So it's on both triangles. So what I'm going to do is I'm going to do this. I'm going to draw a triangle like this. And I'm going to say that this is the shorter triangle or the smaller triangle, AOC. Let me do it again. Do something like this. Does that work? Yeah, perfect. Remember, this is the fixed point O. Remember, A is here. C is going to be here, isn't it? Yeah? It's going to be, let's do this. It's going to be C. Like, it's a triangle AOC. Now, remember, let's look at the picture. We can see that O is on both uh, triangles, right? A to O is on both triangles. So what essentially that will look like is if I was to draw the other triangle, it's just going to be a longer version. So I'm going to just draw another line like that. I remember this is going to be the point B, isn't it? Like that. So I'm going to just put this as the point B. So there's two triangles here, but remember, O to A is on both. And then obviously to connect this one to make it the triangle AOB, sorry, I'm going to just draw a line like this, aren't I? So I've got two triangles here. Now, if I just look at the triangle in green, the smaller one, triangle AOC, right? Remember, the area of this triangle is going to be the perpendicular height times the base. So the perpendicular height is going to be the perpendicular from that point O all the way down here. I'm going to call this H. Yeah? And we know this is the distance A to C. So let's just say, for example, that this triangle AOC had an area of K. I'm going to put a K here in a box. This is the area of this green triangle, yeah? I'm going to say the area of AOC is going to equal K. And what that would mean then is, well, the formula is going to be half times the base, which is A to C, right? Times the height. This is equal to K, right? This is a fact. Half times base times height. Now, how does that compare with the triangle AOB, the larger one? Well, if you think about it, right? If you just look at the outside, you can see that the perpendicular height remains the same, doesn't it? For both triangles, perpendicular height remains the same. So the area is going to be proportional to the base, right? And what that means is, well, if I wanted to figure out the area of AOB, right? Well, this will be equal to 1/2 times the base. But remember, the base is A to B now. But remember, we know from this here, from part I, lambda was 3/2, right? To go from the yellow line, which was A to C, to the green line, A to B, we times by lambda, which is 3/2. So the scale factor is 3/2. So what I can say here is that I'm going to just write here, AB is equal to 3/2 AC, isn't it? So what I can do then is say this is equal to half times AB times H, and that is just the same as half times 3/2 AC, right, times H. Now, if I compare these two, let me put these underneath each other actually so it's super clear. Like that. If I compare these two right here, well, the only difference is that one of them has a multiply of 3/2. It's just the exact same thing, right? The only difference is that I'm multiplying this one by 3/2. So therefore, the area of AOB, right, the larger triangle is going to be 3/2K, isn't it? Because I'm going to times that by 3/2 as well. Meaning that the ratios are just going to be, I'm going to say AOC to AOB, right? The area of AOC we said was K. We know the area of AOB is 3/2K. Now tidying this up, I can divide by K, 1 to 3/2. And if I times by 2, I get 2 to 3. So therefore, the ratio is 2 to 3. Now, you don't have to do all of this. Some of you may have been able to just do it very quickly, but it's a walkthrough. So I just want to make sure it's very clear and concise. But yeah, that's pretty much it. And that will give you the full marks. And what is this? This is question 13. Okay, so question 14 says, find in simplest form the coefficient of x to the 5 in the expansion of 5 plus 8x squared multiplied by 3 minus a half x to the power of 6 for 5 marks. Okay, so this one, as you can see quite clearly, it's a binomial expansion question. So you want to remind yourself of the formula, which is a plus b to the power of n, and this is equal to a to the n plus n choose 1, and then you drop the power of a by 1, n minus 1, and then the b appears, b to the 1 plus nc2, and then you just decrease it by 1 like that, and then you're going to increase the b by 1 as well, and then all the way up until the a term disappears and you're left with b to the n. So this is your formula here. So for me, when I look at this, by the way, we've got a 5 plus 8x squared, so it's not that straightforward. We're going to have to expand as well. But in terms of just the 3 minus a half x to the power of 6, right? What I like to do is say, okay, well, fine. This minus a half, I can actually write as a plus, and then I can put a minus in the bracket like this, can't I? Like that. So that tells me quite clearly that our a is going to be 3. Our b is going to be a minus a half x, and our n is 6, isn't it? And then I'm just going to follow that formula. So, however, as I said before, we've got a bracket here. So I'm going to write 5 plus 8x squared, like that. And then I'm going to now apply the formula now. So what will happen is that the first term is going to be a to the n. So it's going to be 3 to the power of 6, isn't it? And then plus nc1, so it's going to be 6c1. And then it's going to be 3 to the power of 5. Power drops by 1. And then the b, which is a minus a half x in this case, is going to increase, isn't it? It's going to appear now power of 1. And as you can see, 5 and 1 make a 6. These powers always have to add to make 6. And then continuing it, it's going to be 6c2 and then 3 to the power of 4. And then minus a half x to the power of 2, isn't it? Minus a half x to the power of 2, and so on and so forth. Now, when you're doing these types of questions, they don't want you to expand everything because it takes too much time. You've got to be clever with it. Now, remember, they're asking us for the coefficient of x to the power of 5, right? So what you want to ask yourself is say to yourself, okay, well, fine. How can I get x to the power of 5? Bearing in mind, once I do this expansion, I'm also going to have to expand it as well. And it's not too bad. Once you just do it a couple of times, it's pretty easy to see. So I'm just going to write this out one more time. So we've got 5 plus 8x squared. And then I've got 3 to the 6 plus that there. I'll just do 6c1 and then 3 to the 5 minus a half x to the power of 1, right? I'm just going to leave the first term. And then we'll ask yourself, okay, well, if I'm expanding this, remember, you need x to the power of 5, don't you? Let's start with this 5 here. If I was to expand, I'll be doing this one, and then that one, and then the term after that, and so on and so forth. But remember, think about it. You need x to the power of 5. I've got a constant term here. If I do 5 times 3 to the 6, well, that's not going to give me any x term. The next one, 5 to the power of this term right here, I'm only going to have an x term with a power of 1, right? So that tells me that I'm going to need the term that gives me a power of 5, isn't it? So what I'm going to do is say, okay, well, fine. Based on that, I know somewhere down the line, I'm going to need a term, so I'm going to write dot, 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 which has x to the power of 5 in it. So what I'm going to do, I'm just going to write need. I'm going to need x to the power of 5. And then if I look at this, now you don't have to do all of them. If you look at the pattern, you'll be able to figure out what terms you need. So I'm going to extrapolate this here. Now, because I need x to the power of 5, it means that this term here will have to have a power of 5, wouldn't it? Like that. So put a 5 here. Now remember, that means that this is going to be a 1 now, isn't it? Because remember, these two powers have to add to make 1. I have to add to make 6, sorry. And then it's going to be 6 choose. Now remember, if you look here, this here is always the same as that. You can even see in the formula, that is always the same as that. That is always the same as that. So since I have a 5 here, it's going to be 6 choose 5. So the term I'm looking for when I expand it with the 5 is going to be this right here. So what you're going to say is that one of the terms you're going to use is going to be, I'm just going to say here, I'm going to do 5. Remember, I'm going to do the 5. I'll write here actually so it's clear. It's going to be 5 and it's going to be 6c5 and then 3 to the 1 and then minus a half x to the 5, isn't it? And if I do that, let me rub out these two arrows here. If I do that and that will quite clearly give me the term that I'm looking for, because remember, I need an x to the power of 5, don't I? So what I'm going to do is say, okay, fine. This term here is just going to be 5, and it's going to be times 6, choose 5, 3 to the 1, and then it's going to be minus a half x to the power of 5. And then I need to work out what that is eventually, and I'm going to do that later. But I'm going to find out how many times I need. So that's one way I can get a term with x to the power of 5 in this expansion. Is there another way? Of course there is. Well, if I write this up one more time, 5 plus 8x squared, and then again, you know what I'm going to do? I'm just going to copy this actually, just so it saves a bit of time. Let me copy that there. Just need that. And paste it here and then bring it there. Just like that. That's exactly what I need. Okay. So, looking at that, remember, we've done the term with 5. There's only one way we can get a power of 5 when we times by the number 5, right? It's one of the last terms here, this one. Now, we need to get x to the 5, but we're going to times by this one, isn't it? So again, just follow the pattern. If I do that and that, that's just going to give me an x squared because this is a constant term. This one will give me x to the power of 3, isn't it? Because I've got a 2 here and I've got a 1 there. That will give me x to the power of 3. But remember, I need an x to the power of 5. So which one do I need? Well, it's quite clearly, we need the x cubed term, don't we? We need x cubed, right? Because when I do x squared times an x cubed, that will give me x to the power of 5. So what term is that? Again, we're going to extrapolate that and see what we need. So again, if I was to do this here, it's going to be, I'll do it underneath actually. It's going to be, if I extrapolate this one, we need it to be a cubed. So I'm going to put minus a half x to the power of 3 there, like that. And then this is going to be 3 to the power of 3. Remember, these two powers have to add to make 6. And then remember what I told you before? This one here is going to be the same as the choose. So it's going to be 6c3, isn't it? Because these two always have to be the same, don't they? Yeah, as you can see here as well. So this is the term I'm going to use, right? And I'm going to multiply this by the ax squared, isn't it? So I'm going to write it here so it's super clear. It's going to be 6c3 and then 3 to the 3, and it's going to be minus a half x to the power of 3, like that. And then now you can see quite clearly, if I was to do that times by that, then if I look at the x terms, I'm going to have an x squared there, and I'm going to have an x cubed here, aren't I? So that's going to give me x to the power of 5. So therefore, I can say that it's just going to be, I'm going to do ax squared times by 6c3, and then 3 cubed, and then minus a half x to the power of 3. So when I work out what these two are, I'm going to just put this in a green box here. These two, I need to work out what these are, and then this will give me the answer. There's no other way I can get a power of x to the 5 if I do the expansion. These are the only two ways. So it's going to be these two I'm going to use. So I'm going to just work out what these are. What I'm going to do, I'm just going to grab this here. Why not? Grab this box over here, and then just work out what this is, and then do the other one. Okay. So with this one, I'm going to label it number 1. We'll call this number 1. So this one right here, let me rub out the box now. Okay. Now, if I was to tidy this up, it's going to be 5 times by 6c5. Whoops. 6 choose 5. And then it's going to be 3 to the 1, which I know is 3, but I'm just going to keep it like that anyway. And then remember this one right here, we can just expand this. This is just going to be minus a half, right, to the power of 5. And then it's going to be x to the power of 5, isn't it? And that way, this here becomes my coefficient. So all I need to do now is just punch this into the calculator. That will give me the coefficient for that term. So I'm going to do that. Get my calculator here. Clear that. And then that will give me, I can do it here, can't I? Yeah, I've got room. I can do it here. That will give me 5 times 6 choose 5 times by 3 to the 1, which I know is 3, but I just want to be meticulous. And it's going to be times by minus a half to the power of 5. Now let's see what I get for that. That gives me minus 45 over 16. So I'm going to say this here, I'll do it here. It's going to be minus 45 over 16, and it's going to be x to the power of 5. That's going to be one of the terms. And then the last one is going to be this one over here, isn't it? So it's going to be, I'm sure, number 2. It's going to be ax squared times by 6c3, 3 cubed. Put in a bracket so it's clear. And then minus a half, and then x cubed. And then what I want to do is simplify this. So it's going to be ax squared times by 6c3 times by 3 cubed. And then this minus a half x cubed, I can write it as minus a half to the power of 3 and then x cubed, isn't it? And then when I look at this here, I've got an x squared term here, and I've got an x cubed term here. When I times those two together, that's going to give me x to the 5, isn't it? So all that means is that I just need to put 8, 6c3, 3 cubed, and minus a half cubed all into my calculator. And that will give me the coefficient for x to the power 5, wouldn't it? So what I'm going to do is I'm going to put that in. So that's going to be, here, I'll do it like this. Yeah, that's fine. It's going to be 8 times by 6, choose 3. You know, just because I'm a bit scared that you won't be able to see the calculator, I'll do it on this side. All right, so it's going to be 8 times 6, choose 3, times by 3 cubed, like that, and then times by minus a half cubed. Let me just double check. 8, yep, 63, 3 cubed. Yeah, that's all good. And that gives me minus 540. So therefore, I can say that this term here is just equal to minus 540. And then remember, x squared times x cubed is x to the power 5. So you get this here. And now what I'll do, just so it's super clear, you can see that this in yellow is the calculation of that above in yellow, and then obviously x squared times x cubed is x to the 5. So this is our answer here. So therefore, the answer for the coefficient, right, what we need to do now is just add these two terms together. So this one here and that one there. Yeah? All we're going to do is just say we've got a minus 45 over 16. And then we're going to minus, if I add it, obviously plus and the minus make a minus, going to be minus 540 x to the power of 5. And this is equal to, all I'm going to do now in my calculator is going to be minus 45 over 16, minus 45 over 16, minus 540. This gives me that number there. So minus 86. Is that 85? Yeah, 85 over 16 all to the power times by x to the power 5. So therefore the coefficient, I'll just write here, therefore coefficient, all right, coef for short, coefficient is equal to minus 8685 over 16. And that will be your answer, and that will give you the 5 marks. Okay, so question 15 says the curve C1 has equation y equals 8 minus 10x plus 6x squared minus x cubed. The curve C2 has equation y equals x squared minus 12x plus 14. Part A says verify that when x is equal to 1, the curves C1 and C2 intersect for 2 marks. Now, this one here, you've got to be very careful, right? It's not a show that question, it's just verify. So whenever you see verify, that just means you're substituting. So you could be tempted to say, okay, well, I'm going to make these two equal to each other and then use algebra to solve it, but it's only 2 marks and it does say verify. So all you need to do is just substitute x equals 1 into both of these equations and show that you get the same y coordinate. So I'm just going to do part A here. Now for this one, I'm going to plug in, I'm going to say C1. I'm going to plug in x equals 1. So I'm going to do 8 minus 10 lots of 1 plus 6 lots of 1 squared minus 1 cubed. This is equal to 8 take away 10 plus 6 minus 1. And this is equal to 8 take away 10 is minus 2 plus 6 minus 1. This is equal to minus, this is going to be 4 minus 1, isn't it? Which is 3. Okay, so we've got one answer here. Let me just double check. Yeah, that's fine. That's equal to 3. And then if I plug in C2 now, what I'm going to expect is when I plug in x equals 1, I should get the same thing. So it's going to be 1 squared minus 12 lots of 1 plus 14. And this is equal to 1 minus 12 plus 14. Now this is equal to minus 12 plus 14 is positive 2. 1 plus 2 is 3. So they both equal 3. So what you can say here is that the point 1, 3, right, lies on both curves, right? On both C1 and C2. Therefore, when x is equal to 1, the curves intersect. The curves, and you're just copying what they asked you to verify. The curves C1 and C2 intersect. So you always want to give that concluding statement as well. So that's all you need to do for that one. Perfect. So that's part A. Now part B says the curves also intersect when x is equal to k. Given that k is less than 0, use algebra to find the exact value of k for 5 marks. Okay, so if they intersect, what that means is that the equations are going to be equal to each other, right? So in this case, we're trying to find the other solution. Now we're going to use algebra to actually figure out what these values are. So I'm going to make C1 and C2 equal to each other. And I'm going to do C2 first because the x squared term is positive. So I'm going to say x squared minus 12x plus 14, right? This will equal C1 because they intersect, 8 minus 10x plus 6x squared minus x cubed. Now, bear in mind, a solution to this is x is equal to 1, isn't it? Because we figured it out from part A. So just bear that in mind, right? X equals 1 is the solution to this equation. So what I need to do now is tidy up. It's a cubic because the highest power of x is a 3. So I'm going to move everything from right to left. So it's going to be x squared minus 12x plus 14. I'm going to take 8. I'm going to add 10x. I'm going to take 6x squared. I'm going to add x cubed. And this is all going to equal 0. Now tidying this up, I'm going to have x cubed, and then let's do the squared terms. I've got a x squared here, and I've also got a minus 6x squared here. That's going to give me minus 5x squared, isn't it? Minus 5x squared. And then the x terms is going to be a minus 12x, and I'm going to add on 10x. Minus 12 plus 10 is a minus 2, so it's going to be minus 2x here. So minus 2, minus 2x like that. And then I've got 14 take away 8, which I know is 6. So I get that is equal to 0. Now I need to solve this equation. Now remember, we figured out in part A that the solution to this equation, right? One of them is x is equal to 1. And obviously this is the same equation. It's just been rearranged. So a solution to this one, solution is x is equal to 1. If I plug x equals 1 into that, I'm going to get 0 because we've shown that in part A. All right. But how was that helpful as well? Well, if you think of this here, if you treat this as a function, let's just say this was called f of x right here, right? Let's just say this was f of x. Well, if I plug a 1 into that, I get 0 out. This is a polynomial. This is just a factor theorem, isn't it? So this is another type of question you can get where you're going to use the factor theorem to help you out. Because if that's the case and you get 0 out, that would mean that x minus 1 is a factor. So what I'm going to say here is that since x equals 1 uh, gives f of x to be 0, right? If I plug that in, I'm just going to, let me put f of 1 actually, yeah? Yeah. What this means is that x minus 1 is a factor of f of x. Factor of f of x. Due to the factor theorem. And now what that means is that I can use long division with x minus 1 to divide this polynomial to get the other factor, right? So that's what we're going to do. So I'm going to have x minus 1, and I'm going to use long division to divide, what was it, x cubed minus 5x squared plus, was it plus 2x? No, it was minus 2x, sorry. Minus 2x plus 6. Plus 6. So I'm going to use long division to figure out what the factor is. So remember how we do this? I'm going to first do x cubed. I'm going to do this one divided by that. That gives me x squared. And then that will go here. And I'm going to do x squared. And I'm going to multiply by the factor we're dividing, which is going to give me x cubed minus x squared. And I'm going to put that underneath here, x cubed minus x squared. And I'm going to take these away. That will be 0. Minus 5 minus x squared. It's going to be minus 5 plus x squared. Or minus 5 plus 1, which is going to be minus 4. So it's going to be minus 4. Go in there, x squared. And then I bring this down. And then I just repeat. So now what I'm going to do, I'm going to do minus 4x squared, and I'm going to divide this by x. So I do this here, minus 4x squared divided by x, that's going to give me minus 4x, and that will go on top. And then I'm going to times minus 4x by our divisor, which is going to give me minus 4x squared plus 4x, isn't it? Yeah, that's fine. And then this is going to go here, minus 4x squared plus 4x. And then again, I'm going to repeat, take this away, take this away. These two are the same. It's going to be 0 all the time. Minus 2 minus 4 is going to be minus 6x. And then I bring down that plus 6 and then repeat. So now I'm going to do minus 6x, and I'm going to divide by x, aren't I? So minus 6x divided by x is going to give me minus 6. That will go there. And then I'm going to times by the divisor, which is going to give me minus 6x plus 6. That goes there, plus 6. That will be 0, that will be 0. So therefore it divides perfectly, right? There's no remainder. So this here on the top is going to be our factor. Yeah. So what we're going to say then is essentially what we've done is factorized it. So I'm going to copy this here. Going to copy this here. And what we've done is we've said that this here is just equal to this right here is just equal to the factor of x minus 1, and we're going to multiply that by the factor that we found there, x squared minus 4x minus 6. Now remember what the whole point of what we're doing here. We made this equal to 0. We're trying to figure out what x is, right? We're trying to solve it, right? We're trying to figure out what x is when it's 0. So all we're going to do now is make this equal to 0. Now doing that, we can see quite clearly we're going to have two factors. X minus 1 is going to equal to 0, or x squared minus 4x minus 6 is equal to 0. Now this one we already know from part A. So we're solving this one. Now how can we solve this? I don't think it factorizes. 6 might, no, this won't factorize, I don't think. So maybe we can complete the square. Let's complete the square. So it's going to be x minus, that's a minus 4, it's going to half, so minus 2 all squared. We're going to take 4 away, and then we've got take away 6 is equal to 0, and we complete the square with that. And then that's going to be x minus 2 all squared, take 10 is equal to 0. And now this is very easy. X minus 2 all squared is going to equal 10. I'm going to square root both sides to give me x minus 2 is equal to the square root of plus or minus 10, right? Or plus or minus root 10. Well, I square root both sides, and that just means that x is going to either equal 2 plus or minus root 10. So we've got two solutions here. Now remember, the question did state that x was less than, sorry, that they stated that k, which is what we're looking for, is negative. It's less than 0. So k are the roots which you found. It has to be less than 0, right? So we can just see quite clearly it's going to be 2 minus, isn't it? Yeah? So 2 minus root 10. Obviously, you can always just check. So let's just see. 2 minus the square root of 10 is negative, it's minus 1.16. And obviously, if I add that there, it's obviously going to be more than 2, isn't it? So 5.1, blah, blah, blah. So therefore, the answer is just, 2 minus root 10, like that. So you're just going to say, that is our answer as k is less than 0. And that's it. And that will give you all of the marks. And that's question 15 finished. Question 16 says, a curve has equation y equals f of x, where x is greater than or equal to 0. Given that f dash of x is equal to 4x plus a root x plus b, where a and b are constants, the curve has a stationary point at 4, 3. The curve meets the y-axis at minus 5. Find f of x, giving your answer in simplest form for 6 marks. Okay, so with a question like this, they've asked us to figure out what f of x is, right, the function, and they've given us f dash of x, which is the gradient function. So what you should be thinking about, well, what is the connection between f dash of x and f of x? It's calculus, right? If they've given us f dash of x, to get back to f of x, we need to integrate. So what you need to remember is that if I have a gradient function, which in this case, they've called it f dash of x, right? I'm going to use function notation. If I integrate this with respect to x, this will give us f of x plus c, right? So that's just something to bear in mind when you're dealing with these types of questions. So so we're going to use that. Now, let's look at the bullet points. We've got the f dash of x, which I'll write out actually. So f dash of x, sorry, that's a bit messy with it again. So we've got f dash of x, and this is equal to 4x plus a root x plus b. And they've told us that the curve has a stationary point at 4, 3, and the curve meets the y-axis at minus 5. So again, there are variables in our function a and b that we need to find. The way you find these variables is you just need to depend on coordinates that you know lie on your curve, right? And there are two. So I'm going to say, just to make a note here, there are 2 points that are on our curve. The curve has a stationary point at 4, 3. That obviously means it passes through it. So 4, 3 is 1 point. And it says the curve meets the y-axis at minus 5. That's just the y-intercept. So we've got two points on this curve that we're looking for. So we're just going to bear this in mind and just keep that. So we need to figure out f of x is, meaning that we need to figure out what a and b are. Now, let us use this bullet point here, the second one. The curve has a stationary point at 4, 3. That just means that dy dx or f dash of x is equal to 0, isn't it? So I'm just going to write SP. SP means that dy dx slash f dash of x, remember, we're using function notation. These are the same thing. This is equal to 0. Yeah? Now, if there's a point, if the point is 4, 3, it means that when I plug in 4 into my gradient function, I will get 0 out for the gradient, right? So all we're going to do is say because of that, therefore, we're going to say f dash of 4, right, is going to equal 0. When I plug in 4 into my gradient function, I should get 0 out if there's a stationary point at 4, 3, which there is because they've told us. So I'm going to just do this now. So based on that, I'm going to say we've got 4, lots of 4, plus a root 4, plus b. This must equal 0. Tidying this up, it's going to be 16 plus the square root of 4 is plus or minus 2, but they did say that x is greater than or equal to 0, so we're going to use the positive solution. So it's going to be 2, so it's going to be 2a, and then plus b is equal to 0. So now I've got an equation in a and b, right? So I'm going to call this equation 1. So this is just a simultaneous equation, right? So we've used that. Now, it tells us that the curve meets the y-axis at -5, the curve itself. So I need an expression for the curve, and we're going to use what I wrote here at the beginning. The integral of your gradient function f dash of x is going to equal f of x plus c. So what I'm going to do now is I'm going to integrate the gradient function. So I'm going to integrate f dash of x, right? And then this is going to give me the integral of, what is it? 4x plus a root x plus b with respect to x. Now doing that will give me well, firstly I need to rewrite this actually. Root x is the same as x to the power of 1/2, isn't it? So I'm gonna replace that root with a half here. And now I'm going to integrate. So integrating this is going to be, I'm going to add 1. So I'm going to do, this is a constant 4. That's a constant. I'm going to multiply that constant by the integral of x, which is going to be x squared over 2. Add 1 to the power, divide by the new power. Plus a. A is a constant. We're going to multiply that by the integral of x to the half. We're going to add 1 to the half, which is going to be 3 over 2. And we're going to divide by the new power, which is 3 over 2 here. And then plus, now we're integrating a constant. Whenever you integrate a constant, you just do the constant times the variable you're integrating with respect to. So it's just going to be bx. And then plus c, your constant of integration. So I'm going to call this f of x now, because this is an expression for f of x. I'm going to tidy up. So I'm going to say f of x will equal 4 over 2 is 2, so 2x squared plus, when I divide by 3 over 2, that's the same as multiplying by 2 over 3. So it's going to be 2 over 3a x to the 3 over 2. Whoops. 3 over 2 plus bx plus c. This is an expression for the function f of x. Now let's have a look at that second bullet point. They told us that the curve meets the y-axis at -5. So the y-intercept is -5. So that actually tells us what c is, isn't it? I'm just going to say c equals -5, right? Since 0, 5 lies on the curve. Yeah, based on that third bullet point. Right? Or if you're not convinced as well, all you could do is literally plug in x equals 0 into here and replace this with 5 and you're going to get c equals, so replace it with -5 and you're going to get c equals -5 anyway. So what I can then say so far then is that if I copy that, so I need to copy that whole function. If I copy that and I put this, yeah, I'll just put it underneath. Put that there, and then all I'm going to do is I'm just going to rub out the c and replace it with -5. So we are here so far. Now remember, we're trying to figure out what f of x is. That's the question. F of x is right here. This is our answer. The issue though is that we've got a and b. We need to figure out what those constants are. Now again, when you're dealing with these types of questions whereby they ask you to find a function and it's given in terms of a and b, you're just depending on coordinates that you know that pass through your curve or your line or whatever it is, so that you can just use substitution to figure it out and create a simultaneous equation. So I'm going to just copy this here again. I'm going to grab this. Whoops. I'm going to grab this here. And I'm going to put this here. We've got this there. And then we've got 2 points based on these two bullet points. Remember, the curve has a stationary point at 4, 3. So we actually did use this for the stationary point. But remember, that's just another point that passes through our curve. And the curve meets the y-axis at -5. So I'm going to grab these two based on those two bullet points. So I'm going to copy this here. I'm going to copy this here. And also, so we've got -5 from there anyway. We're going to use 4, 3, right? Because if I use -5, it's not going to give me anything. So I'm going to plug in 4, 3 into that. Yeah. So if I do that, it's going to be 3. This is going to equal 2, 4 squared plus 2 over 3a. And then it's going to be 4 to the power of 3 over 2 plus b for -5. And I'm going to tidy this up now. So what I'll do is put this, what's that? 4 squared is 16. 16 times 2 is 32. That's going to be 32. Plus, let me use a calculator before I make any silly mistakes. So I'm going to just work out what that is. So 2 over 3. And I'm going to times this by 4 to the 3 over 2, isn't it? Just to figure out what we get. That gives me 16 over 3. So it's going to be 16 over 3a. And it's going to be plus b times 4 is 4b minus 5. Now, tidying this up, I'm going to move everything. I'm going to move the constants from right to left to bring it with the 3. So it's going to be 3 take away 32 plus 5 is equal to 16 over 3a plus 4b. And again, let me put that into my calculator just to see what that is. 3 minus 32 plus 5, that's equal to -24. So what I can say then is that what I can say then is that this becomes 16 over 3a plus 4b is equal to, what was that? -24. So that's another equation in terms of a and b. Remember, we had one already at the very beginning. 16 plus 2a plus b is equal to 0. So I'm going to call this equation 2, and I'm going to grab that other one as well. So now it's just a simultaneous equation. Copy this here. Okay. So here. And then I'm going to tidy this up a bit as well. So I'm going to say then, just based on that, that there tells me that I've got 2a plus b is going to equal -16. That's equation 1. And then equation 2, I'm going to write again, 16 over 3a plus, what is it, 4b is going to equal -24. I've got two equations. I can just punch this into my calculator now, can't I? It doesn't say anything about not using the calculator for technology. So I can just solve this simultaneously on the calculator. So I'll do that. I'm going to get menu, and then I'm going to go to equation. I'm going to go to 1, so this equation. 2 unknowns, and then it's going to be 2, 1, and it's going to be -16. Like that, and it's going to be 16 over 3. It's going to be 4. It's going to be -24 here. Equals, that means that x, which is a in our case, is going to be -15. And b in our case is going to be 14. So we now know what a and b is. Remember, the question asks us to figure out what the function f of x is. This was our expression for f of x. So what I'm going to do is copy this and then plug in a and b, and then we're done. So copy this here, and then plug in our values for a and b, and that will be it. So it's our function f of x. When I plug in a and b into that, I'm going to say f of x is going to equal 2x squared plus 2 over 3 times by -15. That's a. X to the 3 over 2 plus 14x minus 5. And then that will give me 2x squared. What's that? -15 over 3 is 5. -15 over 3 is -5. Times that by the 2, that's going to be -10. You can punch this into your calculator as well. So you get that there. And then you got 14x minus 5. So therefore, this is our final answer in its simplest form. Let me just double check. 2x squared, that's fine. -15 over 3 is -5. Times it by 2, -10. Perfect, perfect, perfect. And that will be it. And that will give you the full marks, the 6 marks for question 16. Okay, question 17 says, in this question, p and q are positive integers with q greater than p. Statement 1, q cubed minus p cubed is never a multiple of 5. Part A says show by means of a counterexample that statement 1 is not true for 1 mark. Okay, so we just need to find an example that contradicts this statement here. So we've got two cube numbers, and apparently when we take the difference between them, it's never a multiple of 5. Well, if you want to prove that's not true, what I would think to use is a guessing game. It's only 1 mark. You can just try anything, but you may as well choose multiples of 5. So I'm thinking, first of all, 10 and 5, right? 10 is greater than 5. We can cube them, see what the difference is, and see if it's contradictory. So I'm going to say part A. I'm going to do 10 cubed, take away 5 cubed. What is this equal to? 10 cubed, take away 5 cubed is equal to 875. That ends in 5, so it's a multiple of 5. So I'm just going to say 10 cubed minus 5 cubed is equal to 875, which is a multiple of 5. Multiple of 5. So therefore, statement 1 is not true. Is not true. And that's it. That will give you 1 mark. Part B says, statement 2, when P and Q are consecutive even integers, Q cubed is minus P cubed is a multiple of 8. Part B says, prove using algebra that statement 2 is true. Okay, so it's a proof question. And apparently P and Q are consecutive even integers now. Remember, if they're consecutive even integers, then, well, what is an even integer? I could say, the smaller one, I could say, for example, P can be 2n. That could be one integer. Remember, that's an integer times by 2. So I'm going to say P is equal to 2n. And if I want the next even integer after 2n, I'm going to add 2 onto it, aren't I? So I'm going to say Q is going to be 2n plus 2. Yeah? And I'm just going to say n is an element of the integers, just so it's clear to the examiner. We are using integers here. Now, all we're going to do to prove that it's a multiple of 8 is literally plug in P and Q into this formula here. So I'm going to say Q cubed minus P cubed will just equal 2n plus 2 all squared. Take away 2n, sorry, not squared, apologies, cubed. All cubed. Take away 2n all cubed, like that. Now doing this is not too bad. So this is going to give me 2n plus 2, 2n plus 2, and then a 2n plus 2. And then this is going to give me, if I cube that, then I'll do it here. 2n all cubed, right, is the same as 2 cubed times by n cubed, isn't it? 2 cubed is 8, so that's just 8n cubed. So that's 8n cubed over there. So that's fine, that's done. I need to work out what this is. Now, I'll do these two here. If I expand those two brackets, then that's going to give me 2n and a 2n will give me 4n squared, plus 2n times 2, which would be 4n, plus another 4n plus 4, plus 2n plus 2 minus 8n cubed. And tidying this up, this will give me 4n squared plus 8n plus 4, and then 2n plus 2, and then minus 8n cubed, like that. And then expanding this one now, it's going to be 4 times 2, which is 8. So it's going to be 8, and then n squared times n is n cubed. So 8n cubed plus this one here, which is going to give me 8n squared, like that. And then this and that is going to be 8n, and 8n times 2n is going to be 16n squared. And then that's going to be a 16n plus, and then the last one is going to be 4 times 2n is 8n. 4 times 2 is 8. And then we're minusing the 8n cubed, like that. And then now we need to tidy this up. We can see quite clearly that this 8n cubed and that minus 8n cubed are going to cancel, like that. And we've got 8n squared plus 16n squared, which is going to be 24n squared, plus 16 plus 8 is going to be 24 again. And then we've got plus 8, aren't we? Don't we? So what we have here is, remember, we've taken the difference of the cubes of two consecutive even integers, and we've got down to this result. And remember, the question asks us to prove that statement 2 is true, which this is a multiple of 8. Now, if this is a multiple of 8, it means that I'll be able to take out an 8, which you can do, can't you? Because 24, 24, and 8, they all have a factor of 8. So we'll take out an 8. That will give me 3n squared plus 3n plus 1. No? Yep, that's fine. Yeah, that's okay with me, I believe. Yeah, that's fine. And remember, n is an integer, so anything here is going to be an integer. No, if I plug in any integer into this expression in the bracket, I'll get an integer out. So I can actually say that this is just 8 times an integer, right? And we know that 8 times an integer is just a multiple of 8. So therefore, we've proved it. And now you're just going to finish off by writing a conclusion statement. Therefore, then you're just going to write the statement again, right? When P and Q are even integers, I'm just going to screenshot it because my handwriting isn't the best, but you always want to just write the actual statement that they're asking you to prove again, right? So therefore, we've done all of that. So therefore, your answer is going to be, therefore, when, hold on. Yeah, therefore, when P and Q are consecutive even integers, Q cubed minus P cubed is a multiple of 8. And that's it. Done. And that is the entirety of paper 1 for the AS 2023 series. Hi guys, Daniel here. Hope you guys are doing well. So yeah, that concludes the end of paper 1 for the AS series for June 2023 at Excel. And yeah, as you can see, there was quite a few questions in there, but obviously we made it to the end now. So hopefully the video, the walkthrough has helped you understand any questions that you maybe didn't in the past, or it's just helped you to consolidate anything that you just needed reassuring on. But yeah, just want to say a big thank you for all the support. If you know anybody that would be interested in these videos, feel free to share it with them. Again, always make sure to like, comment, and subscribe. And yeah, what else is there? I'm definitely be doing a lot more walkthroughs in the future. So if there's any ones in particular that I haven't done on my channel that you want me to do, then just let me know in the comments. And I also offer group classes as well that you may be interested in. So I'll leave all of the information in the description for that. But again, thanks for watching and happy studying. See you guys soon. Take care.